professor. He is a senior assistant professor from EC and also the head of the department of MANNU, Maulana Azad National Urdu University, Hyderabad. So her educational qualifications are Master of Engineering, Signals and System Processing from Osmania University, Bachelors of Engineering, Electronics and Communication from Mukafamja College of Engineering and Technology, Osmania University, Hyderabad, Diploma in Electronics and Communication Engineering, work experience with over 21 years of experience in the field of teaching. Hajira Fathima has been serving as the head of the department in Electronics Communication Engineering Department as a senior assistant professor at MANNU from since 21st May 2012. She has demonstrated leadership by overseeing departmental activities and guiding students to excellence in the field of electronics and communications. She also has a hands-on tool on operating systems, programming languages, and software packages like PHP, ICE, Multisim, MATLAB, Code Composer, Studio X, like that. So Hajira Fatima ma'am attended the workshops and summer school courses, research methodology in the University of College Engineering, Osmania University, induction program, UGC, HRDC, AMU, Aligarh, and FDP wireless and mobile communication, artificial intelligence at MANNU, industrial training on fiber optic communication. So she guided the ME projects of high performance FFT architecture and BE projects on implementation of adaptive noise cancellation using DSP processor and real-time implementation of audio signal processing using DSP processor and distributed arithmetic FIR filter implementation. So she conducted workshops coordinator for the 1 week FDP also for application of remote sensing and GIS to engineering problems. Co-coordinator for the online ATAL FDP on advancement in sustainable energy management and environmental protection in Jan 2025. She published a paper on design and development of a robust phase shifter algorithm for adaptive digital beamforming. Hajira Fatima ma'am, she decided to further her academic and professional career in teaching and research with a focus on electronic and communication engineering. She is actively involved in various academic activities and has a track record of conducting successfully workshops and faculty development programs. So I would like to call our today's speaker, Dr. Hajira Fatima ma'am. So congratulate ma'am as a speaker panel member. So your session will start now. I'm handing over to you.
Thank you, Jalaluddin sir, for such a nice introduction.
Thank you, ma'am.
Very good afternoon to all the participants of this faculty development program. As sir gave me my introduction, I'm Hajira Fatima, currently working as a head of the department and assistant professor in Electronics and Communication Engineering Department of Maulana Azad National Urdu University, Polytechnic. I'd like to share my presentation now.
She's pursuing.
Is my presentation visible to all?
Yes, ma'am, it's visible. You can carry on.
So in the next 1.5 hours, I'm going to speak about the integration of renewable energy into the Indian grid. I hope the slides are changing.
Yes, ma'am.
Yes, okay. So fine. Now we are going to focus on this 5 topics to integrate renewable energy into the Indian grid. The understanding of these 5 topics is much important. We'll be starting off with renewable energy. Yeah, and this faculty development program started from Monday onwards. I think you might have come across renewable energy sources and what are the different sources, how they are being generated, and which one is predominant in India as well. So what is renewable energy and what are its unique characteristics? Why it has become so unique that we need to discuss on its integration into Indian grid. See, till now we never spoke of integrating the conventional energy sources, power generated by conventional energy sources like thermal energy or hydro energy into Indian grid. Now there's some need to discuss on the integration of renewable energy to our Indian grid. So a little understanding on this is required. Next is the Indian grid. In what way the Indian operating grid is unique, and is it ready to accept the integration of renewable energy? And what are the real challenges which comes across when we try to integrate this renewable energy power generated by these renewable energy sources into our operating Indian grid? And if there are challenges, then what are the options? What are the solutions? What are the options available to overcome these challenges? And what's the future that is awaiting the sector, which paves waves for our young engineers and research scholars to work on those areas, the prospective areas which are of need for the country right now. Coming to the introduction, renewable energy generation has become a very important topic in recent years. Post Paris Climate Summit, as per United Nations Framework for Climate Conversion Change (UNFCCC), India has committed some goals, of which the most important was to have a 30% of installed capacity of energy generation based on non-fossil fuels based energy sources. India is so comfortable until that point of time with coal-based energy generation because around 80% of energy generated was through this thermal-based systems. And we have got so many number of advancements, developments, and efficiencies have been consistently improved by using this conventional energy generation methods. And the grid was also very comfortable with it. But post 2016, there has been so much of impetus on development of renewable energy owing to environmental concern and for having a sustainable development coupled with energy security. And across the globe, there are too much of efforts going on. Few countries have crossed great achievements while European countries have done well. India by that time was so primitive, but now it is the fastest developing in terms of renewable energy, and it has aligned itself towards the global pathway and has set a target of 450 gigawatts in terms of megawatts. We could say it is 450,000 megawatts of renewable energy capacity to be achieved by the year 2030. For your understanding, as of now, the entire grid installed capacity is only 380,000 megawatts. But in the next 6 years, we are aiming to establish renewable energy sources for 450,000 megawatts of energy. So, such large scale penetration of a unique kind of energy into the Indian grid requires a lot of innovations and some disruptive non conventional changes are expected. Why? Because of the nature of renewable energy sources, which don't act as a base load as of now, but it is expected that they are going to give energy as base load. But those things are for future. This penetration has got a future. You have got a target which requires detailed analysis, and that detailed analysis is going to come in the next part of our session. Renewable energy. By this term, what is renewable energy? Two terms can be used to define it more precisely. That is, one is it is clean. The renewable energy so generation is clean without polluting the environment, and it is replenishable. It is restored. It can be restored. You don't annihilate something, you don't exhaust something, which is a natural source which comes again and again. So clean and replenishable, non-depletable, these are 2 to 3 characteristics which speaks about renewables. While all other sources are depleting, maybe your fossil fuels, it's highly depleting, maybe your nuclear, it's depleting. While these sources of renewable energy don't deplete, they keep on restoring. Some sources of renewable energy are hydro, wind, solar, biomass, geothermal, ocean energy. you have got large number of sources of renewable energy. But in Indian context, we don't have large hydropower plants. Are I could say they are not brought under renewable energy sources in India. They are a separate category. And small hydro plants less than 25 megawatts capacity are being taken as renewable energy sources. Now, next wind. Wind and solar are predominant. Uh, Coming to wind energy, India is bestowed with wind-rich sites. So we have got some developed wind generation sources. Coming to solar, India being a tropical country has got good potential for development of solar energy. And we still have good amount of solar capacity installed as of now. Next is biomass. Agricultural land has got a good source of biomass. Next is geothermal, ocean energy. They don't fare well in Indian context, but those are available in other nations where they have got the potential. So these are some sources of renewable energy, in particularly in Indian context. Wind and solar gains utmost importance and gets our attention. Now we'll see the characteristics of these renewable energy sources. The renewable energy sources has got the few of these characteristics, which pose as a challenge to the operating Indian grid system. See, we know that the renewable energy is clean, it is non-depletable, but the challenges are it is intermittent. It means it is not continuous in nature. It operates for a specific period of time in a day, maybe 8 hours, or in some locations in some locations which has got some good solar radiation, maybe 10 hours. And variability. Solar comes with that characteristics variability. As far as variability is concerned, this particular source of renewable energy comes for a season. If we consider wind energy, say June, July, August, normally we get more wind generation in these months. After that, in the months of like November and December, the same source which was running at its rated capacity will be idle. So the wind generation happens only for a period, for only 2 to 3 months. After that, it goes to zero at times. So it has got a character that it is not consistent with demand. Demand will never change that way. Demand will be there for 365 days and 24 hours a day. But these renewable energy sources are intermittent and have characteristics of variability. Now coming to point 2, which is uncertainty. As a matter of fact, we do not have control over the natural parameters. Either it, you know, the sun irradiation, the clouds passage, or the wind speed, we don't have a control over it. And it is a bit hard to forecast it. It is tied to meteorological forecast. It does not support grid security. Say, for example, grid at times requires a little less power, or at times it requires more power because of demand, which is happening over there. So we could say that we don't have a control over these parameters, whereas in thermal power plant, based on need, you can actually control it. You'll be able to generate the power based on demand, more or less as per the demand within the capacity of the power plant. Or like we say, you'll be able to generate comfortably less if the power demand is less, and if power is not required much, and you can generate you can increase the generation of the power capacity a little bit as per the capacity of the power plant when the demand is more. So these conventional power generation systems have the flexibility to give flexibility to response to the demand. So uncertainty is one important challenge which is associated with renewable energy sources. The point 3 is locational dependence. Though India being a tropical country, We have solar potential rich in deserts, and wind potential is rich in offshore locations. But the load centers are not there in deserts. Load centers are located somewhere nearer to the urban areas or urban locations. Hence, generation is at one point and the necessity is at another point, which is necessarily not very close. It will be very far off. So these renewable energy sources are located or location dependent, unlike conventional sources of generation. You can neither transfer the raw material or nor your source of generation. You have to establish you have to establish this power centers compulsorily at the places where we have a good amount of sunlight or good wind velocity. Where in conventional systems we have got an option of power plants, we have got an option to establish the power plants at load centers where power is actually required. Now the point 4 is non-synchronous technology. These renewable energy sources are connected to grid or the consumers through power electronics rather than any rotating equipments. And so photovoltaics receives sunlight and it converts it into electricity. While this electricity is in the DC form and your grid operates on AC. This DC is to be converted into AC in an inverter based on power electronics, then connected back to it. Similarly, wind turbines are operating on variable speeds, where variable speed AC is converted to DC, and this DC is again converted to AC and is pumped into the grid because of quality issues. So, it is non-synchronous technology. Unlike your thermal power plants, your turbine runs turbine generators is coupled with that based on frequency. We have certain technologies associated with the frequency governing mode of operations. In case if frequency rises above a set value 50 hertz, your turbine automatically unloads. In case if frequency goes a little bit below the set value, your turbine based available stream can generate a little more based on limitations. A lot of factors are there, but it responds, but this conventional methods responds to the grid requirements. Uh, uh, we call it as grid services. Neither solar or wind can respond to the grid requirements. It is entirely out of control and it depends only on nature. Next, coming to this wind generation, which is more in few months and which is very negligible in a few months of the year. It is coupled with intermittency and variability. Wind energy is based on seasons, we could say months. It is more or good in the months of June, July, August. As you can see, there's a peak over here in the graph for the months of June, July, August, and a bit of September. This peak generation takes place in the months, in these months. The same goes to zero by December. So it becomes a non-reliable source of energy generation because we can't depend 100% on it. This is a way how a wind turbo generator works. Now coming to the solar day generation, how a solar power is being generated in a day, in a span of a day. It is also coupled with intermittency. The solar power generation is also coupled with intermittency. On a day's generation, it is marked. It will be marked for every 15 minutes. How solar power generation, PV-based power generation works. If you see this graph, power generation starts by 7 o'clock and it comes down by around 6 or 7 in the evening. And does the grid requirements or does anyone works on this necessarily? No. But we have the requirements 24 hours a day. in this period also it is not and if we see this graph in this period from early morning like around 7 o'clock till evening 6 to 7, in this period also it is in the form of a peak. It is not flatter, it's not a smooth graph. This may be due to climatic changes, due to cloud movements, due to wind, due to dust, and a lot of things, a lot of parameters are there. And we don't have control over these parameters. Next, we'll be seeing with the uncertainty. As I told you that there are no power to dictate. We don't have any power to dictate what would be a generation by this time, because it depends on so many number of factors. If you take wind power depends upon number of factors. It depends upon humidity, it depends upon rain, ambient temperature, dust concentration, wind speed. There's a lot many factors which comes into role on its generation. We could say these are the characteristics. Similarly, solar generation depends upon cloud movement, dust concentration, rain, and the solar irradiation, because it has impact of the temperature of solar PV modules. If the temperature of the solar PV module is less, relatively less, the power generation will be more. If the temperature of the solar PV modules raises, the generation of the power gets reduced. So you have a kind of uncertainty about the power generation. So we don't have a control or a kind of ability to predict and tell that this would be my power generation by this time of a day, which is actually very much required when we integrate these renewable energy sources to the grid. At no time we can tell that so and so amount of power will be generated by this time, which is very much required for a stable operating grid. The next is this solar atlas. It is locational dependent. The solar power energy is this source itself is a locational dependent. It is not same everywhere. It varies from place to place, location to location. Even in India, though it is a tropical country, we are in a mid generation range where the generation capacity is around 16 lakh units per 1 megawatt per year. At some, on an average, we could say, at some locations like Rajasthan desert, they offers a little bit more, around like 20 lakh units per 1 megawatt per year. It depends upon irradiation factors. So, establishing a unit or a project at such places is economically viable, and at places where it is generally 16 lakh units or lesser than the 16 lakh units will not be viable option, because it may affect the economics of the plant. The plant economics will be seriously dented. So plants based on solar, if established at high potential zones, your economics will support you. In places of low potential, lower power generation will happen, which will directly impact on the economics of a plant. The next is wind potential. Once again, this is also location dependent. Like you can say, wind potential is different across the globe. Like in states of Tamil Nadu, if you consider India, in state of Tamil Nadu, we have got certain locations where potential of getting wind power is more. The average speed is more than 6.5 meters per second. So it is locational dependent. We could say it is also a locational dependent source of energy. So establishing wind power plant at places where wind potential is more will be a good idea. The next one is non-synchronous power generation. This non-synchronous technology. So we don't have any rotating equipment in solar power plants. It can be taken as a supporting factor, or we could say as a negative factor, because rotating equipment basically requires higher maintenance cost. But here, even though you don't have it, you can't support during grid requirements. When the demand is more, we are not able to supply that much of power, and we are not going to we are not reacting as per the grid requirements. The point two is connected through only power electronics. We call it as support, or during start operation, these renewable energy sources can't be dependable sources like conventional plants, which can be used whenever the grid is blacked out. That can be used as that. So these are connected through power electronics and not through mechanical systems and other things. So that's what we have been discussing about this renewable energy sources, the characteristics, and how they operate at different conditions, different months of the years, and at different places. Next, coming to Indian grid. As now we have got a little bit idea, a little bit understanding of this renewable energy sources and its characteristics. Like they are clean, they are non-depletable, they are intermittent, they are locational dependent. We have an uncertainty associated with it, and they are non-synchronous in nature, and they are seasonal dependent. Seasonal variability is also there. Now we see about this is all about the renewable energy sources. Now we'll see about our Indian grid, because we are taking like we are talking about connecting this, like what we are interested in now is we are interested in connecting these renewable energy sources to our Indian grid, and we'll see what are the characteristics of the Indian grid. And our grid is so unique. Our Indian grid is also so unique with two peaks and two lows on a same day. It is not normally a flat curve throughout the day. Our requirement is not same at all times of the day. If you see this Indian demand plot on some one particular day randomly chosen, if you see this, how there's a demand of power at different times of a day. Normally, no grid will be in a flat position, but ours is too unique. The Indian operating grid is too unique. You can make out from this graph, you could see that this is an actual demand that is met for a particular day on the 30th of December 2023, which has been chosen randomly. A maximum of 180 megawatts of demand is achieved on that particular day. And we have two peaks and two lows. Normally, early morning low, somewhere around 4 a.m., you can make out from this graph. By 9 to 11 o'clock, it will reach one peak. Then again, it will settle down by 3 to 4 o'clock or 5 o'clock. It again reaches a peak at 7 o'clock in the evening. Here, a requirement is not flat, not a particular graph suitable for renewable energies, because a solar energy which runs for 300 days generates its peak by 12 to 2 p.m. It generates maximum power in the time of 12 to 2 p.m. But that time, our Indian grid requirement comes down, and it does not generate power. The solar energy power plant, it does not generate power by 7 o'clock in the evening. But our requirement as per the Indian grid is too high at that time, by the evening 7 o'clock. Evening peak is there. So there's a variation. When it is wind, for the 3 months, June, July, August, no doubt it will give a real flat, or we could say a little lower during daytime. Otherwise, it's a real flat curve. But solar, 300 days morning peak, it rises and reduces, not matching with the actual demand that is persisting in our Indian grid. Now we'll see the source-wise generation. This is the way the demand was met with various generation sources, because we have thermal, we have nuclear, we have hydro, we have wind, we have solar, the different energy sources. Solar, the yellow line in this graph shows it starts by 7 o'clock and gets down by 6 o'clock in the evening. Its portion is very less, because you need to compare with this right hand side generation megawatts. 200 megawatts. While coming to thermal energy, the power generated by this thermal energy plant, it acts as a base and contributes to the major portion of energy requirement. We can make out from this graph that thermal, it contributes to the major portion of energy requirement. All other sources contribute only little, very small portion when compared with the 100% requirement of the Indian grid. When it comes to wind contribution is also very less. Hydro, it acts as a cushion, the blue colored line. The power generated by the hydropower is being represented with using a blue colored line, which has got one peak, then it comes down, and again it takes another peak, acting as a cushion for accommodating this solar energy. If you couple this hydro energy and solar energy, you can make out this yellow colored line and the blue colored line. If we couple these two different types of energy sources, we can have a little bit smoother. We can't say flat, but we can have a smoother curve, because when the solar energy is so power generated by solar energy is less, we can have a hydro power and when the power generated by hydropower is at its low, we can have a solar power. So we can say this hydropower is acting as a cushion for accommodating the solar energy. But India being an agricultural country, we can't expect this always, because hydro plants are based on reservoirs, and reservoirs discharge based on agricultural requirements also. Always we can't discharge as we like. Always we can't stop when we don't want to do it. It is an interlinked parameter. It is not a standalone parameter. That's what we are going to emphasize over here. So this is a way how a particular demand on a particular day was met with various energy sources. Next, coming to source-wise contribution. In terms of contribution, this brown color, the thermal power contributed the biggest, while the yellow one is for solar, is a very small part. The green is for wind energy, a very small part. Hydro acted as a cushion. This is just to show presently that thermal acts as a base load today, as of now, and solar is contributing a very little. Next, coming to this demand position, to show variation in demand. Like from this table, from this chart, we could say this. We can make out a different instance of time in a day. The demand is varying. At early in the morning, 3:35 a.m., the demand is 1,22,000 megawatts. And 9:48 a.m., the demand is 1,82,000 megawatts. And at 11:20, it is 1,80,000 megawatts, and so on. And if we take out the variability, the difference, the variation is being given in the last column, and we can make out from this that the maximum variation of the demand on a particular day is 60,000 megawatts. There's a maximum variation of 60,000 megawatts per is there on a particular day. The variation that has happened on the grid, on this particular grid, in this grid, from the morning low by 3:35 a.m. to 9:48 a.m., it has ramped out to 60,000 megawatts. Too much of variation was seen on this particular day. To that extent that your grid requirement, your demand requirement is on a single day, there is a variation of about plus or minus 60,000 megawatts. It's a very big value. It's a huge value, we could say. A variation of plus or minus 60,000 megawatts requirement, which is so unique when compared. This characteristics of our Indian grid is very unique when compared to other countries, and which is so unique when in terms of renewable energy generations concerns, because you need to accommodate it there. And to that extent, though we have such a huge variation, we should to take out some means to accommodate, to meet the demand by making use of renewable energy sources. This is the energy mix statistics. From this, we can see that on that particular on a particular random day, we can make out that 75% or 77% of energy required was met through the baseload plants, coal and lignite, while renewable energy sources, wind and solar, contributed only 10% of it. And this is not to show that this is the way the Indian grid operates. We can't say always there'll be a variation. We can't say that always there'll be a variation of 60,000 megawatts. It is subject to too many number of changes. Some on some other random day the variation can be quite less. On some other day it can be quite more than this 60,000 megawatts as well. It depends upon various factors, various parameters. On some other day, this Indian demand plot has been one more random day has been selected to plot this Indian power demand throughout the day for 24 hours. It should if from this we can make out that it's nearer to a flat. This curve is nearer to a flat with the difference between low and the peak. It's not too high, so that what our Indian grid requirements are so unique when compared with other nation requirements. On a particular day, maybe a flat or relatively flat at sometimes, and maybe having a steep rise of about up to 60,000 megawatts variation on some other day. So we need to see to respond to these variations in the demand by generating the appropriate power by making use of renewable energy sources as well as by using the conventional sources, which is actually being done till now by using conventional sources. This demand position for that particular day for this graph, you can make out that it is more or less, it's a bit a flatter curve only. On this particular day, in the last column, we can make out that the maximum variation of power is 32,000 megawatts on this particular day. On some other day it was 60,000 megawatts. On this particular day it is 32,000 megawatts. So grid is so season dependent. We can say that the grid in the Indian grid is so season dependent. Our generation is season dependent. Grid demand is also season dependent, and so that is what we try to emphasize upon. And this is the energy generation where mix bar chart being shown by making use of conventional methods of generating power and by making use of renewable energy sources. All along what we have been done, and to what extent has renewable energy, in terms of energy, we don't speak in terms of installed capacity. Installed capacity is different. Today, of the installed capacity of 3,32,000 megawatts in total, Indian grid comprises of 3,82,000 megawatts of power, and we approximately have only 92,000 megawatts of renewable energy sources. And in this 92,000 megawatts of renewable energy sources power, 40,000 megawatts of power is being generated by solar, 39,000 megawatts of power is being generated by wind energy, and all other renewable energy sources will contribute and make it to 92,000 megawatts of power. But in terms of generation, that doesn't reflect, because thermal plants operate at higher output, at an output of around 85% plant load factor, while renewable sources such as solar acts at only 19% capacity utilization factor, and wind at 27% utilization factor. They generate very less when compared to thermal. And so when we look at this bar graph for some specific year chosen randomly, only 10% of energy is contributed by renewable energy sources. So far, every month, approximately only 10% of the energy is being generated is through our renewable energy sources, and it is very small as compared to this conventional methods of energy generation. Now we can see this capacity addition projection. What is the projection? We have projected 4,30,000 megawatts of power to be generated by 2030. By 2030, we have to achieve, more precisely, 4,35,000 megawatts of renewable energy power, which is actually coming around to be 53% by 2030. And by 2040, as per the government of India, we have to go up to 5,97,000 megawatts of power. So the challenges of integrating these renewable energies with Indian grid also are also expected to increase with the increase in the contribution of this renewable energy sources, power generated by this renewable energy sources. The challenges which are going to come to integrate it when we are trying to integrate it in with the Indian grid will also be more. This renewable energy Indian context, this is a split up of what that is going to form a part of this particular generation. Of all the sources of energy, solar is expected to swell to a larger extent, and it is expected to reach to what do you call it as 3,67,000 megawatts by 2040, and 2,80,000 megawatts by 2030. So that is the way these two sources, solar and wind, are expected to grow in the days to come. Here, the prediction is being given for wind energy, for solar energy, biomass, and a small hydro sources of energy as well. This was a typical breakup for 175 gigawatts of breakup for power generation. In this, we can make out that 1 lakh megawatt of solar energy power generation is expected to come, and wind is expected to reach up to 60,000 megawatts. And to attain this much of threshold levels, government is offering so many schemes to increase the generation of solar and wind power generations. Hydro is expected to reach 10,000 megawatts, and biomass a very smaller value to be of 5,000 megawatts. This target was set by government of India to achieve it. Now, after seeing the characteristics of the renewable energy sources, the characteristics of the Indian operating grid, now we'll see what are the challenges in integrating this renewable energy to our grid. Now we need, and what are we supposed to achieve it? And so we'll see these challenges in detail now. This comes to the issues. One side we have, and on one side we could say that we have this unpredictable, uncontrollable generation, and on the other side we have incalculable demand. So on either way, we are compelled to have challenges. On one side, we are not able to perfectly predict what is our demand on, and on the other day, we don't have the control over the generation of the renewable energy sources. So on the either sides, the things are not in our hands to control, but these two has to be smoothly integrated to achieve better results. Now we need to take out the ways. What are the solutions, the ways to smoothly integrate this renewable energy systems and yet to meet the demand of the grid by these renewable sources. These are the major challenges. Just a minute. Indian grid was dominated by hydro. We know that during the initial period, the Indian grid was dominated by hydro. and is then for the replaced by thermal generation. But now it has to give a way for renewable energy sources. Now we'll see this major challenges. The point one is unmatched generation and demand. There's a no match in the generation and demand. The normal peaks of the demand as per the Indian grid occurs 2 times a day, at early morning 10 o'clock and at evening 7 o'clock. And the major sources of renewable energy, solar, is not available by 7 o'clock evening. So what to do? What to do? This is one point of concern when we go for solar energy. So it is one point we can take it as a challenge over here, and we'll see how to overcome it as well. And the point two is non-responsiveness. Say uh, we are coming to a particular place where for demand our generation should for some particular demand our generation should respond, but renewable energy sources are nature dependent. They does not respond to grid, does not respond to the grid needs. Again, this is also challenging. Always the source, the grid should be in such a way that the renewable energy or any conventional energy sources should be in such a way, the energy sources should be in such a way that they should respond to the operating grid. When the power requirement is less, the sources, energy sources should be able to flux the generation of the power to the requirement of the grid. And when the power requirement is more at some peak timings, then at that time this energy sources should be able to generate more power to meet the demand. Uh, this is the point two, and the point three is must run status. As per the government of India, it has given a must run status for solar and wind power generations. And at no point of time we should curtail the power generated by solar or wind energies, because once we curtail the power generated by these renewable energy sources, it badly affects, it badly hits the economics of the plant. So at no time we can curtail the flux, the power generated by this renewable energy sources as per the orders from the government of India. This is also a major a matter of concern, which is must run status. And the point four is cost perspective. Renewable energy projects are land sensitive, unlike conventional projects. Actually, there's a thumb rule. 1 megawatt of thermal power generation requires 0.5 acres of land, whereas 1 megawatt of solar plant initially required 5 acres of land. So you can make out that there's a huge difference in the requirement of the land. Now, due to this technological developments, the land requirement for the generation of 1 megawatt of power generated by solar power plant has reached to around 3.8 to 4 acres per megawatt. But still, we can say that there's a huge difference in the requirement of the land when compared the solar energy power plants with this conventional energy plants. While 1 megawatt of thermal, in terms of generation, if we speak, 1 megawatt of thermal generates 87 lakhs of units in a year, whereas a solar will generate somewhere around 16 lakh units only. We call it as low CUF, low capacity utilization factor. So here, this is also a matter of challenge for us, that it's giving a very low CUF. And the next thing is high transmission cost, because it is located, because this solar and wind, these renewable energy sources plants are located at somewhere, and it will not be located at the load centers. They are not located at nearer to the load centers where we have to transmit the power that is generated. The load centers are somewhere, and these plants are located at somewhere. So we need to have some means to transport this power generated by this renewable energy sources from the plants to the load centers where the requirement of this power is more. So high cost is associated with the transmission aspects related with renewable energy sources. So these are all some major challenges that are enforced into the system by the renewable energy sources. Though now we have come to know like what are the challenges which are associated with the integration of renewable energy sources to our Indian operating grid. So we have challenges. Now we'll see what are the options, what are the ways, what are the solutions to overcome these challenges to integrate our renewable energy sources to our what do you call it as uh, Indian grid. We have the options as well to overcome these challenges. And what are the options now? Now we need to think like we need to make out what are the options that need to be developed, and what are the best practices that are being used in other countries to overcome such challenges. Because Germany is a particular country which on one particular day it has met its entire power generation through renewable energy sources only for a period of time of a day. When when that is possible by one country, then why not us? Why not it's possible by India? Or what did they do and to achieve it, and what are we supposed to do to achieve such things? We'll see to it how to achieve such things. This is integration. It is through this integration waves. Um, Overcoming these challenges by making use of few integrating ways as our options or the solutions, we could say. What are the available integrating ways we can make use of uh, to integrate this renewable energies? There are four best options which are being practiced in the other countries as well. Yeah, and we could say that these are the we can say that these are the four best options which are being practiced globally to integrate renewable energy source power to the respective operating grids. The first one is wider balancing area. When we have wider balancing area, the demand and the generation can be shifted. If the power plant, solar power plant or the wind power plant are being are located at places where we have the high solar irradiation and high wind speeds, and if they are generating the solar power and the wind power at those particular areas, the power generated from those plants need to be transported to the places where we have a high demand of the power requirement. This is known as wider balancing area. The next is energy storage systems. We can make use of chemical storage systems to store the energy when the more power is generated, and to make use of the same energy when there is a more demand in the grid for the power. We can store the energy and we can use whenever there is more demand, we can use that energy which is being stored in the chemical storage devices. The flexible systems. We should make the renewable energy systems to be flexible to respond to the operating grid. Whenever there is more demand, we should be in a condition to supply more power, and whenever the demand is low, the system should be able to flux themselves to cater to the needs of the operating grid. And next is forecasting and scheduling. Forecasting is related to the meteorological forecasting of the weather, the solar irradiation, we could say, the wind speed. This, if by proper forecasting, we'll be able to generate the power more appropriately with the increased efficiencies. And scheduling of the generated power can also be, various methods can be taken out for scheduling it to cater to the needs of the operating grid. We'll see one at a time. This is wider balancing area, what are the available methods over here is one particular location where there is demand, and there's one particular location where there is generation. So you can couple them. We know that 12 to 2 solar power generation is at its peak. Then find out where is the demand, where the demand is more in this particular period, in which areas of our country we have more demand in this time period from 12 to 2, and couple the power from this solar power plant to those areas, supply the power generated by this solar plant to those areas, transport it to the required place. This is known as wider balancing area. It is a low cost methodology available for integration as of now. Regionally, the grid system should be spread across. Like the Indian grid is a synchronous. We have in the Indian grid, we have five subsystem grid stations. Like we have northern grid, we have southern grid, we have eastern grid, we have western grid, and northeastern grid. At some point of a time, let us say if there is a power generation is more at a northern grid, and the demand of power is more in the southern grid, then the power can be transported supplied from the northern grid to the southern grid where the demand is more. At some other point of a time, when if the power requirement, the demand of the power is more in some northeastern grid, then it can be supplied from the place, from the grid, wherever the power generation is more. From that grid, the subgrid, we can transport the power to the grid where the demand is more. In that way, we can try to have a balance of demand and the supply of the power by making use of this renewable energy sources. Also, we can, by using this balancing method, we can meet the requirements of the operating grid, the demand of the operating grid. The next is the energy storage system. One more option or the integrating method is energy storage system. Here the challenges are renewable energy sources are seasonal, they are intermittent, we know about it. And what are the options over here? The options are pumped storage systems and battery energy storage systems. Presently, it's a costly affair. We could say it's a costly affair. The levelized cost of energy storage is somewhere about, for one unit, it is somewhere around 6 to 8 rupees through batteries. So we could say presently, as of now, it's a costly affair. Because we are going for this chemical storage systems, the cost of storing the power in this through these batteries is a bit high. In hydro systems, we can make use of this pumped storages, but it is a bit complicated because it depends upon various other parameters which need to be taken care of. So we could say that it is a bit complicated. When coming to this battery BESS, battery energy storage systems, with the development in the technology, we could say that the cost may come down in the future time. The cost of the batteries may come down to some extent with this developments in the technology in the storage systems as well. And the next one is EV and incentives, electric vehicles, utilization of the electric vehicles. As you might be knowing that Government of India has set a target that 30% of the vehicles on road by 2030 will be electric vehicles, and all these electric vehicles will be using batteries. So we can make use of the batteries of these electric vehicles. We can ask them to charge this batteries of this electric vehicles when the demand is less and the power generation is more, and they can give it back. Then discharge these batteries when there is a they can give this power to the grid by discharging the batteries whenever the demand is more from the grid side. We can make use of this electric vehicle batteries also by planning it in this way, by giving some incentives to them by discharging the batteries at the peak times, and we can ask them to charge the batteries at the low demanding times when the demand of the power is less, at that times we can vary the tariffs. We can give lesser tariff at low peak times, so that this non electric vehicle, the whenever the requirement is less, people can make use of the power at that time. Next is flexible systems. Here, the demand and generation need to meet. Shedding in demand, you have to shut down the options. Planning in place should be there, and minimum generation whenever the demand is less. When the demand of the power it is less at some low time areas, at a particular time of a day, if the demand of the power is less, the systems, the energies, power generation systems should be able to flux the energy, flux the power generation to cater to the demand of the operating system. The way the conventional operating systems operates, both this hydro and thermal systems, they flux itself. Generally, fluxing of up to 55% of the operating capacity is done. When a plant is of 100 megawatts, we can go up to 55 megawatts of power generation fluxing. Whenever demand is less, we can flux the system to generate less power, and whenever the demand is more, we can within the capacity of the power plant, we can try to generate the more power during this ramping characteristics. When there is a lot of variation in the demand of the power, the plants should be able to cater to the needs of the operating grids. With the advancements in the technology further, still we could say that in the coming years the fluxing will be still improved, but by still maintaining the stability of the power generation units and supporting the Indian grid system. The last one is forecasting and scheduling. And there's forecasting and scheduling the renewable energy sources. It is the cheapest way for properly planning your generation for a particular period of time. If it is not required in your grid, where it can be pumped, or where the demand it can be pumped to the place where it is demanded. Where the power demand is more, we can pump it to that place. So by forecasting is related to this meteorological forecasting, predicting the solar irradiation and the wind velocity. By precising this prediction, we can generate our power by making use of renewable energy sources more accurately. And we can say, if a prediction is good, we can say by this time of a day, or by this this amount of power can be generated by using solar power, or by using wind power, or some other renewable energy sources. And planning should also be done. If one place, as I have already mentioned, that if at one place if the power generation is more, and at some other place the power demand is more, then the proper planning, this power need to be supplied or transported from the generation point to the location where it is more in demand, where the power requirement is more. We should opt out for some supply methods or transportation methods. Now coming to way ahead, what's this is going to dominate in future. These are the few things which are going to have a very good future over here. This is the first one is the flexibility in the thermal generations can be developed still to the next level. And the next one is the investment in solar power plants is increased to an extent, and a lot of technological changes are going on. Technological developments are going on in solar panels to generate more power. And government is also encouraging by providing various schemes. Government is also encouraging to come up with more and more solar and wind energy plants. The next one is utilization of hybrid generation. So here hybridization, we know that the wind energy power generation is having a more or less a flatter curve, and the solar energy power generation curve is a peak, is a sort of a peak in the during the mid day region. So by integrating, or we can say by coupling this wind energy and the solar energy, by hybridizing this solar energy and wind energy, we can come up with a hybridized system which can cater to the needs of the Indian operating grid by providing a so smoother or flatter curve throughout the day of the power required. We can also see for hybridizing the solar energy with some other renewable energy sources as well. And the last one is trying with storage options. A lot of developments, research is going on in the storage systems as well. So we can say mechanical storage systems can be opted out, gravity based storage systems can be used. A lot of innovations and development is going on in this area as well to cut down the cost of the batteries which are used to store the power. Now, all these are the promising areas for our future. Research scholars are there, or for engineers, we could say. So, would like to conclude this talk by saying that growth on renewable energy is imminent, and adaptation to the change is the need of an hour. Rather than pointing difficulties, we should come up with the solutions to overcome these difficulties. We can't say this is the challenge, this is the difficulty. When we make use of renewable energy, the efficiency is less, like the power is that they are not able to cater to the demand of the grid. All those challenges are there. Now there is a need of an hour to come up with solutions, to options, to overcome these difficulties and make use of these renewable energy sources in a power grid. Uh, so this innovative, economic, and flexible power generation is the future. With this, would like to conclude. With this, I would like to conclude the session. If you have anyone has any doubts, you can just have any queries, please you can go ahead. Participants, if
Hello. Hello, ma'am. Ma'am, thank you for the wonderful session. So, participants, if you have any doubts, please post your doubts, questions in the chat box. Chat box is open now.
and an off day as well, there are participants of more than 100. It's very good enough to see such
Yes,
an
ma'am.
active participation of the participants.
Yes, ma'am. From day one, it's consistent. So, participants, the chat box is open now. You can post your queries here so that the speaker will clarify your doubts.
Any doubts, any queries, please go ahead. So I'll take it as no queries. So would like to thank the coordinators for giving me a chance to present a session on this
Ma'am, ma'am,
energies.
sorry for interruption.
Yes.
Just now the chat box has opened, ma'am. So
Oh,
the
fine,
questions
fine, sure,
arrived. Ma'am,
no issues.
Ma'am, one questions arrived in the chat box.
What are the current prices of renewable energy generated? See, more precisely, we can't say per unit generated by renewable energy source is this many rupees. It depends upon the factors like which type of renewable energy source we are using, solar power plant you are using, or you are using the wind power plant, and what is the efficiency of that power plant, and where that power plant is being located. It depends upon these factors to come up with the price. As of now, we can say that as compared to conventional methods, it's bit high only because it is not fully established. Though it's been established in India, there are many challenges we need to overcome still to make them work as an alternative to conventional methods. There's one question by Sai Kumar sir. It is, what are the main challenges of integrating renewable energy sources like solar and wind into the Indian power grid? It's already been like I have discussed in the session as well. The main challenge is when we go with the solar power plant, the power generated by solar power plant is only for a specific period of our time in a day, from morning early morning 7 o'clock till evening 7. We'll have a power generated in the form of a peak. In the other times of the day, we don't have the power generated by solar power plants. And coming to wind energy, also we have discussed that the wind energy curve, when it generates, when the wind velocity is good, we'll have a more or less, we could say, not flat, but we can say that we have a smoother curve of the power generated by the wind energy. But wind energy, we can make use of the power generated by wind in in few specific months only, like June, July, August, or at the mid of September, till mid of September, we can have a good amount of power generated by these wind velocities. But in the other months of the year, it may go down literally to zero as well. The power generated by this wind power plants will be less. How do you see the future of renewable energy? The future of renewable energy is going to be very challenging, and it is the future. We need to come up with the solutions to use these renewable energy sources as an alternative to conventional systems through the research and all development activities. A lot of research work is need to be done in these areas. The scholars are the young engineers, those who want to do research in this area. It's the most promising and the challenging area where you can work to come up with the solutions to overcome the challenges of the renewable energies, to make it as an alternative to this conventional energy systems, which are depleting at a faster rate. Still any more sessions? I hope I have answered all the questions. We will look for some more questions in case if you have.
Yes, ma'am. One question arrived, ma'am, from Mauna. Why is India not doing offshore wind like Denmark, in spite of having long coastal line?
Just a minute, sir. I'll see where it is. Can you please post it once again? The one who has posted. Why is India not doing offshore wind?
Yes, ma'am.
The thing is, like, it's a very nicely asked, very good question, I could say. I thought of covering one more point. See, when we see a few countries like Denmark, if I'm not wrong, when the power generated by that country is more as compared to the demand, what they has done is they have shared their power with the transported or supplied their power to the neighboring countries. And I have mentioned that in India we have subgrids like northern grid, southern grid, eastern grid, western grid. When the power requirement at one grid is more, when the demand in one grid is more, and it is not able to cater to the needs, and the power generated at some other grid is more, then it can be supplied. We are following it, we are implementing it within India, but there are few countries, they are following it, they are sharing the power with the neighboring countries as well. In case in future, if we have good terms and relations with our neighboring countries also, we can share our power, if in case if you are able to generate more power with respect to the demand, with the demand, if you are able to generate more power, we can share it with the not only within India, all parts of India, with the neighboring countries as well. What is one of the main objectives of India's national wind solar hybrid policy? Nowadays, like if we just go for a solar energy plant, or if we just go for wind energy plant, sometimes will not be able to cater to the needs of the operating grid demand. So when we make use of hybridizing this solar and wind to cater to the needs of the operating grid to the maximum extent, to meet the demand of the operating grid, this the objective will be to meet the demand of the operating grid to the maximum extent. What is the primary function of green energy corridors being developed in India? The primary function will be to make use of these sources as an alternative to our conventional energy systems, conventional energy power generation systems. Electric vehicles are much simpler. Mona has asked one question that aren't electric vehicles are much simpler than hydrogen-based vehicles. Though electric vehicles are much simpler, there are various parameters which need to be considered. There's a reason these hydrogen-based vehicles are also being being in research and demand. Any further questions?
Hello, participants. You have any doubts? Please post your queries in the chat box. Sir, one question, sir, again.
Yeah, this is some question that what are the current trends and policies supporting the integration of renewable energy into the Indian grid? Now, see, as I have told you that in one of the slides, the government of India has set the target as to achieve more than 50% of the power generated by renewable, and to make use of the renewable energy sources power to be as a more than 50% as compared to the conventional sources. So that need to be achieved. Any recent breakthrough in battery storage technology? A lot of developments are going on to cut down the cost, to improve the capacity and of this battery storage systems. Mona, I hope I have answered your question. Was there talk of sodium-based batteries that could be alternative? It could be done. I'm not much into the storage-based systems, so a lot of research might be going on in it as well. Thank you, students. And I thank the coordinators as well for giving me the opportunity to share my ideas with such active participants, and congratulate you in conducting this FDP with such a huge participants, which is going to be, I could say, the unique one. And if I'm not wrong, your FDP might be might be among the few those who have got such huge participants.
Thank you very much, ma'am.
It shows that you have selected the topics which has attracted the participants on. Congratulations, sir.
Thank you very much, ma'am. Participants, still there are 5 minutes. If anybody has a question, they can post in chat box. Once again, thank you for your wonderful session, ma'am.
Thank you, sir. Thank you so much. I'll take a leave then. Thank you so much.
Yes, ma'am. Yes, ma'am. So, participants, the next session will be going to start within a couple of minutes. So, before going to the starting of the session, fill the feedback form of this session. Today's first session. There are 2 more sessions. Hello, Dr. Abdullah, sir. I'm audible?
Yes, I can hear you. Assalamu alaikum.
Wa alaikum assalam, sir. So, sir, within couple of minutes, I will introduce your introduction, then we'll start the session, sir.
As I'm at home now, I would like to add background to my presentation. So, can I do it now or later?
Yeah, it's your wish, sir. You can do it now or before changing the screen or sharing the screen or now itself.
Yeah, but I'd like to add background in Google Meet, so I'm unable to do it now. Do you have any idea? Should I be able to upload so that I can change my background?
I think just to share the screen of slides, automatically it will go for the video part per slides, no, sir. Participants, within a couple of minutes, the session will going to start. Yes, sir, it is visible now.
Okay,
I
but
will enter.
I was talking about the video because if I use the camera, maybe it will be heavy. So maybe after I introduce, I'll off the camera. Is it okay?
Yeah, okay, yeah, okay, fine, sir. Okay, fine.
All right, thank
So
you.
okay, sir. I will start the session now, sir. So before going to the start the session, participants, uh, I would like to introduce our today's speaker, Dr. Abdullah Al Momin, uh, professor in Department of Civil Engineering in IIUM. He completed his Bachelor of Science in Civil Engineering BUT in Bangladesh in '93, Master of Science in Environmental Engineering, University Putra, Malaysia, Doctor of Philosophy in Environmental Engineering, University Putra in Malaysia in 2005. Field of specializations of Dr. Abdullah expertise includes hydrology, water pollution control, water and wastewater treatment, urban storm management, flood mitigation, and integrated river basin management. His professional experience of over 18 years of teaching experience at an international university and 31 years of professional experience in civil engineering, focusing on the water and the environment sector. He has been actively involved in research, acquiring grants totaling RM 1.64 million and conducting research across 25 funded projects. He has presented 104 conference papers and published 88 journal papers. Additionally, he has contributed as an author to one book and editor to three, with 16 book chapters authored. His professional work includes product and process development with 27 awards and 3 patents granted, one pending. Dr. Abdullah has also provided part-time consultancy services on 36 projects. He has supervised 14 postgraduate students and examined the theses of 20, both internally and externally. Furthermore, he has been invited as a trainer, speaker, and session chair for 16 events related to water and environmental engineering. And he has a membership in Chartered Engineering of Council of UK, United Kingdom, Professional Engineering in Bangladesh, Professional Engineers of Registration Board, member in International Association of Hydrological Science, Life Fellow in Institution of Engineering, Bangladesh, member of American Society of Civil Engineers, member of Society of Environmental Engineer in UK, member of Canadian Association on Water Quality, member on International Water Association. Dr. Abdullah continues to make significant contributions to his field through research, teaching, and professional engagement. So I'd like to call our speaker. Sir, it's my pleasure to share a screen with you, sir. So you can start the session now.
Okay, thank you very much. Again, welcome to this session. And first of all, I would like to thank to the organizer to invite me to give a talk on this subject matter. So basically, it is just sharing my experience on how to manage the non-poisonous pollution so that we can manage water resources in a sustainable manner. So that's why I have chosen this topic. And I hope that, inshallah, the knowledge that I shall be sharing with all of us will be beneficial for our academic and professional life. So as I have mentioned, it will be good for us if I can off the camera so that the video is not heavy for us.
Sir. Yes, you
Okay.
can carry on, sir.
Let me do that first. Okay.
Yeah, just go for full screen as well, sir. There
Is
a
it not
pop-up
full?
button.
Is it not
Yeah.
full screen now?
No, sir, it's in small only.
Okay, but
Just
in my
pop-up.
computers, my computer is full screen. I try again. Okay.
Yeah.
How about now? Now?
Yeah, sir. Fine.
Okay. Alhamdulillah. Thank you.
Fine. You can carry on,
Okay.
sir.
So as you know, actually, it is we are 2.5 hour, advance in Malaysia. So
Yeah.
7:30 will be our iftar time. I'd like to try to finish the presentation by 5 p.m. Indian Standard Time.
Yeah, sure, sir.
So basically, as I have mentioned, our main objective today to share some information on the non-poisonous pollution, or it is called also diffuse pollution, or more specifically, when there is rain or snow melt, there will be runoff, surface runoff, and this water carries lots of pollution to the rivers. So this causes a lot of water pollution, and it is important to manage this pollution in order for us to protect our water resources. So in order to understand this presentation better, those who have experience in dealing with hydrology and water quality, that will be very helpful for us. For other audience, maybe we have to explain a little bit more, but it's okay. Let me finish my presentation, then we can have a lively discussion, inshallah. If we look at the water resources, as we know, one of the main source actually rain, although rainwater harvesting is not so much effective worldwide, but still this is one of the important resource. Okay. So if we look at the waters available in the earth, we can exclude the saline water or sea water because this is not readily usable, although we get lots of resources from sea. But when you talk about water resource, we normally refer to the fresh water or sweet water. Okay. So only 3% of the earth's water actually fresh water. Okay. And out of 3%, most of it actually are captured in the polar regions and top of the mountains as ice or glacier. So those are also not readily available. Once the ice melt and it goes to the river, and we can use that water for our activities. Again, about 30% also underground. To extract this underground water, we also need lots of resources like pump. Otherwise, it is not readily available for us. Or maybe hand tube well, but hand tube well is very limited, amount of water we can extract. So basically, we can see out of fresh water, only about 1% is available in different forms, which we can extract easily. For example, lakes and rivers. Okay, and if we look at the surface water only, okay, because these two are remotely available, not directly available. Surface water, outer surface water, 87%, sorry. 87% available in the reservoirs or lakes, natural dams, and about 11% in the swamps or wetlands. Okay, so only flowing water that is convenient for us to tap is the river water, only consists of 2%. Okay, so for that reason, worldwide, river is one of the main resource for water supply. When you talk about water supply, we are referring to irrigation, drinking water, commercial, industrial, and other urban uses. Okay, so we can see from here what a little amount of water actually we can get from the nature with minimum effort, and that is why the pollution of water is very important, because if the water is, this little amount of water is polluted, then it will be difficult for us to continue our daily life and other economic activities. And for that reason, and in the UN Sustainable Development Goals, where there are 17 goals, one of the goal, which is goal number 6, is the clean water and sanitation, very much related to water. Okay. Okay, when you talk about water resource, again, there are two issues. One is the quantity related issues. Okay, sometimes water can be good quality, but the amount is not enough. Again, we have a problem in water resource that is not sufficient. On the other hand, during monsoon, many of the countries actually experience flood when there is more than enough water, but the water is dirty. Again, it is not readily usable. It could be suitable for irrigation, but for most of our other activities, it is not usable. Sometimes this extra water, this flood water, bad quality water actually spread diseases, cause death instead of spreading life. Okay? Although we know that water is important for life, especially for the creation of life, whether it's animal or plant, for the creation of life, for the beginning of life, water is essential. Okay, but continuation of life, depending on the type of organism, it depends, whether we need air or we need water. Okay, but for human being, air is more crucial than the water. Without water, we can survive a few days, but without air, we cannot survive so long. So when you talk about water pollution, then as you know, there are some pollution sources like sewage, the wastewater coming from industries, and also the sewage, the grey water coming from commercial activities or residential activities, from laundries, from hotels, and many other places. These are the point source. So the red color sources I have mentioned here, those are called point source because those are coming from a confined area, okay, from human activities. On the other hand, runoff, okay, runoff mainly generated due to rain. As you know that rain, water is a good solvent, isn't it? So it dissolves many materials, either organic or inorganic. It dissolves quickly, okay? And also when the flow is sufficient enough, it can carry debris, okay, rubbish and floatables. So this is how runoff actually contributes a significant amount of different types of pollution, which I shall be discussing in this presentation, so that we are aware of this non-poisonous pollution, which was not much given focus in the developing countries. If there is any burning question, anybody can actually ask me, okay? It will be lively compared to my monotonous, presentation. Okay, as you have realized that the title of this presentation is focusing on the non-point source pollution. Basically, when there is rain, depending on the amount of rain, there will be some amount of water will flow, isn't it? We call it runoff. Rainfall and runoff is a continuous process, okay? If the rain is sufficient enough, then the soil will be saturated and the excess water will flow over the surface, goes to the drain, and from the drain maybe go to the river and ultimately goes to the sea. While moving from one place to another place, whether it's natural place or man-made, or it's under construction or agriculture, this water will dissolve different types of pollutants, okay? And as you know, the runoff actually is huge quantity compared to the point source pollution coming from the industries, isn't it? From our houses. From the houses, amount of water actually less compared to the amount we receive from the rain, okay? So, whether it's agriculture area, okay, or it can be a construction site, or even natural forest, okay? Actually, the rain can carry lots of pollution from these areas, okay? All the areas, any surface exposed to the atmosphere and subject to the rain will generate non-point source pollution, okay? And the pollutants can be different, which I shall discuss later on. So if we summarize, we can see that based on the pollution sources, we can categorize urban, where it belongs to residential, industrial, commercial, institutional, like universities, school, offices, even recreational facilities, okay? So different type of human activities produce different pollutant. On the other hand, even the rural areas also may produce some amount of pollution, okay? Especially the agriculture activities. On the other hand, this nature of pollution, we can actually classify into point source and non-point source, as I have mentioned, okay? Then the types of pollutants, it can be physical, okay? There are different types of pollutants. Actually, virtually there are unlimited number of pollutants. And these days, with the development of new products, new activities, new commodities, the number of pollutants are actually emerging, okay? It's virtually unlimited, okay? And sometimes pollutant A can react with pollutant B and can produce another different pollutant C. We know that, okay? So I'm not going to highlight on those things. The next type of pollutant can be chemical in nature, okay? Generally, we call chemical oxygen demand, like organic material and inorganic material that can consume oxygen, ammonical nitrogen, total phosphorus, organics, and other inorganics, including heavy metals, and so on, okay? The third category of pollutants can be biological or microbial in nature. For example, bacteria, okay? Fungus, other germs, okay? Which can cause disease like pathogens, okay? So if we focus on the non-point source pollution, often it's referred as the runoff-related pollution, which I have mentioned already, okay? And the problem with the non-point source pollution, it is difficult to confine and identify, okay? When it rains, depending on the land surface, different types of pollution will be generated, okay? Because the rain water will carry these pollutants, all right? So normally, if there is no rain or there's no snow melt, normally NPS pollution is not generated. It is mainly due to the snow melt or rainfall. If there is snowfall, it may not produce runoff, so there will be no pollution that time. But when the ice will melt or the snow will melt, then they will produce pollution while the water will be flowing. Okay. So that's why the understanding the nature of pollution, NPS pollution, is very important. But it requires the knowledge on sources, impacts, and other potential pollution solution that could be crucial not only for protection of the ecosystem, but also for sustainable water resource management. Because for water resource management, as I said, we may have huge amount of water, but if the quality is good, not good, then also we have another issue. It will cost a lot of money to treat this water for human consumption. For irrigation water, there's not much challenge, but for our activity, commercial activities, economical activities, we need clean water, we need treated water. So graphically, if I want to show the different types of non-poisonous pollution from the cropland, it can be produced. Okay, even from the open surfaces where the animal can graze. Then also they urinate, they dispose their poo. So from their from their waste, when it rains, the rainwater will carry this pollutants, different types of pollutants, organic and inorganic, and it will bring to the water resource. So rivers will be polluted, and some of this runoff also, polluted runoff also will infiltrate into the ground and ultimately percolate to the groundwater. It will contribute, pollutant to the groundwater, especially the nitrate and nitrogen related pollutants which are dissolved. So any mineral that is dissolved, that can contaminate the groundwater. Okay. So this is how non-poisonous pollution not only will affect the river water, surface water, or lake water, also it will affect the groundwater, especially with regards to nitrogen compounds and other dissolved minerals like phosphorus and metals, pesticide, herbicide. Those are actually carried by non-poisonous pollution. Okay, I have already mentioned briefly the major sources. Just to repeat again: agriculture runoff, urban. So basically, wherever the rain happens, from there the non-poisonous pollution can happen. And you can see these days we throw plastic here and there, isn't it? So when the rainwater is heavy enough, they will carry these things. So this is a real picture. This is a real situation. Okay, and this we call it garbage or debris or floatables. They just not only contaminate the river, they also contaminate the sea, because ultimately the river water flows to the sea, and these pollutants actually contaminate the sea. And sea ecology also destroyed due to these plastics and floatables. So if you can classify the common pollutants like trash and debris, the floatables, solid waste, sediment, this is one of the major issues for non-poisonous pollution. Either from the construction site, from the agriculture areas, when the soil is disturbed, any area which is disturbed, which is removed from the protection from the grass and trees, it is potential to contribute non-poisonous pollution. So this is the minimum definition that we should remember. Any disturbed soil is potential to non-poisonous pollution when there will be rain. Okay? So that's why the subtropical countries, tropical countries where there is frequent rainfall, they are more prone to non-poisonous pollution compared to the arid regions like the desert areas. Okay, there is not much pollution, non-poisonous pollution, because there is less rain. Okay? Heavy metals. These metals are available in different forms in the urban areas, from the brake pads, from the vehicle exhaust, even from the pavement marking. We have marking, right? Zebra crossing and other marking. So day by day, actually, they deteriorate. They detach from the material, pavement materials, and when the rain comes, these are carried by the rainwater. And these paints normally have heavy metals like cadmium, nickel, and others. Okay, oil and grease another issue, but depends on the area. Leaking from the vehicles, even from the workshop. If it's open workshop, when there is rain, the rainwater will easily detach the oil and grease and carry to the rivers. And the other type of pathogen, pollutant are the pathogens. Okay, microbial like bacteria and other pollutants. Okay, sometimes if the sewage treatment plant is not properly protected, then the flood water can affect the sewage treatment plants, and in that case, the pathogens and the organism can be discharged from the sewage treatment plants due to the overflows. So on my left, this is example of point source, meaning that we know from where the pollution will be discharged. On the other hand, on the right side is non-point source. When there will be rain, even from the forest also there will be pollution generated. Okay, dead corpse, then also decomposed plants, leaves, all these will be carried by the rainwater to some extent. And on the other hand, if any area is exposed to construction, it also will contribute sediment and other pollutants. The problem with the sediment is that, I think many of you know already, sediment is a media. Okay, it carries lots of other pollutants. And like even metals, non-metals, they actually are adsorbed, bound with the sediment. Okay, sediment actually bind these pollutants and carry to the water bodies. Even the bacteria also can be attached to the sediments. So sediment is actually is a carrier of many other pollutants. Once we see that there is high sediment in the river, we can expect that other pollutants also be high. Okay. So just quickly going through the real scenario, how the rainwater can cause pollution. Even the areas protected like this also can generate sediment, isn't it? Depending on the rainfall. Heavy rainfall has lots of energy to detach the particles from the even from the protected soil surfaces. Okay, so these are the sign how the rainwater can cause pollution. Even you see, if we dump solid waste like this, the rainwater will access to this solid waste, and they will leach. They will leach this organic and other inorganic material to the runoff, and that runoff will pollute the drain and rivers. Even once we clean the grass, these grass are not carried, isn't it? So rainwater will carry this to the river system. So these are examples. If we do not maintain our neighborhood properly, there will be a continuous source of non-process pollution. You can see here, one area is protected properly. There's no even the same rainfall. Okay, same rainfall event. This area is protected properly. There's no sediment or non-process pollution. Of course, there will be some dissolved pollutants, metals and other things. But here we can distinctly see that if the area is not protected properly, sediment can generate, and also it will carry many other pollutants together. This is the situation during dry time. Okay, dry time, some of the houses, they discharge water from the kitchen, which is called sallage, or from the washing machine, or from other activities, isn't it? So flow is very small, even though the pollutant concentration can be high. Okay, but the flow amount is small. When you talk about water resource protection from the pollution, actually we should consider the concentration and also pollution load, both. So concentration actually is just milligram per liter, isn't it? Volume, mass over volume. Okay, that is the unit that we express for concentration. So sometimes during dry weather, the pollutant concentration can be high because the amount of water is small, isn't it? For example, we are discharging water from the washing machine. So in that wastewater, the phosphorus and other compound can be high, okay, because the amount is small. On the other hand, during rain, there is sufficient amount of water. You see the drain, same drain actually is full, almost half full, isn't it? So amount of water is very high, but although the pollutant concentration can be small compared to this situation, but the load of the pollution, okay, which is mass of the water, pollutant, or concentration of the pollutant multiplied by the volume of the water. So that actually becomes high. Okay, that is why although the pollutant concentration during the rain time may be small, runoff is small, but actually when you multiply with the flow or volume of runoff, then the pollution load becomes high. So certain pollutants, pollution load is important, especially for we call it conservative pollutants, meaning that they don't decay, like sediment, like metal, they don't decay. But if there's organic material, gradually they will decay due to the self-purification capacity of the river, okay? Or even the bacteria can consume them because they are organic material. So for those are called non-conservative pollutants. So for the conservative pollutants like sediment, metals, the volume, the load of the pollution is important. How many kg of the pollutant we are discharging? Because they will remain in the nature. They will remain in the water bodies. They don't decay. So for non-process pollution, we have to consider both concentration and also pollution loading. So again, you see, during rain, the pond actually is getting more sediment and other pollutants, which is generated due to runoff. Okay. Sometimes we may think that, okay, this is just dry area, there's no water pollution, isn't it? Of course, there's no point source pollution, but when there is rain, the rainwater will carry sediment and it will result the river like this. Okay. When there is no rain, the river water is much better, but during rain, it is actually more polluted, at least with respect to sediment and other certain pollutants. Okay. Same goes to this one. See, this is a timber industry. During normal time, there is no wastewater discharge, okay? But during rain, the runoff will generate, and this is the result from the timber sawmill, okay? Timber mill. So we can see, you see, if we just allow this area without any measure for non-process pollution control, it will continue discharging or contaminating the water resources. So even though this area will not generate any pollution during the dry days, but still we have to take care of for the protection from non-process pollution during rain. Okay. You can see another natural water body during no rain, very clean water, isn't it? Very clean water, very clean. Okay, but during rain, it carries sediment and other pollutants from the forested area. There is no development upstream. It's natural ground, but yet due to solubility of the soil and collapse of the soil particles, erosion of the soil particles, then it becomes polluted. So that's why I hope that my the point that I'm trying to highlight, non-process pollution is very important for the water resource management, because controlling point source only was not good enough. Okay. Again, some same photo during dry days and during wet days, during rainy time. Of course, this sediment was deposited because it was carried during the previous storm. Okay, and the sediment deposition continue adding. Again, during dry day, still better water quality, but during rainy day, you can see that. Okay, another photo, dry day and also rainy day. Same location actually, just upstream and downstream. Okay, two different, same location. So I think besides my claim that non-process point is important, this is an evidence from US EPA. So I believe that now we should agree and realize, those who are new to this topic, that non-process pollution actually very important. And it was decided in 1970s that in USA it was the nation's largest water quality problem. Okay, with regards to impairment of water bodies. Although they tried to control the point source pollution from the industries and other sources, but yet it didn't give much benefit to the recovery of the water source, because they didn't focus on the non-point source pollution. But after 1970s, they are doing well, because they are focusing on the non-point source pollution also, meaning that both has to be controlled, not only one, not only the industries. So I think I have already mentioned that historically, the main focus was on the point source pollution worldwide. And in the developing countries, still we are struggling to control the point source pollution because of actually economy. Any environmental control actually requires fund. Okay, so we have other major issues like food, shelter, medicine, education, which are top priority for our citizen. So we cannot give much focus on the environment to improve the environment. But the developed countries, they have enough fund. They actually did a lot. But yet they realized that doing or controlling the point source pollution only was not good enough. So that's why they ultimately conduct research. They calculate the pollutant loadings, and they found that on annual basis actually there are many pollutants which are contributed from the non-point sources due to rain, due to snow melt, compared to the pollution that generated by the industries, domestic and other point sources. Okay, I hope this message is clear to all of my colleagues here. Then it will be easy for us to continue the remaining session. So those developed countries already have many acts and also regulations. For example, USA, they have this Clean Water Act, and also they have watershed protection approach, because if we protect the watershed, means the catchment or river basin, then there will be less pollution. And for the non-process pollution, one of the sustainable way of controlling the non-process pollution is the source control, which mean that control at source. Let us manage the catchment or river basin properly, so that the pollution is not generated. Just imagine if we want to construct some project, we just leave it bare, open, without grass and other tree protection for a long time, for a few months, then what will happen? There will be lots of erosion, isn't it? So for that kind of situation, our construction method should be good enough so that it doesn't generate unnecessary non-process pollution. If we just leave the soil disturbed for a long time during rain, it will carry lots of pollution. Similarly, you also have many initiatives to control the non-process pollution. But as I said, in the developing countries, we are still struggling with the point source. So let alone our target to control the non-process pollution. Because for non-process pollution, I think you can imagine, the amount of water to be controlled or treated is huge. Okay, and normally there is no small or specific treatment plan for non-process pollution control. I will discuss at end of my presentation that there are normally, there are natural systems like pond, wetlands, which actually help reduce the pollution from the non-point sources. Okay, so it requires huge amount of land and other initiatives to construct and also to maintain the non-point source pollution control facilities. So it is not easy compared to the point source. Okay. So although the control of non-point source pollution started in 1970s, yet the research is still ongoing. Okay, this is a recent publication. I would like to acknowledge that much of the materials that I have used in my presentation actually taken from the internet and various sources. But to minimize the content, I didn't mention the specific sources. But many of them are actually from internet. Besides, I have some research project. Those are actually photos and many other things also from our own studies. Anyway, if we look at here, the orange color is total citation and the blue is publication. So starting from 2012, which is from here, we can see that number of publication increasing. That means although the this topic actually already 50 years, almost 50 years old, but still more research to be done, okay, so that we can find efficient ways to control non-process pollution. Okay, and if you can see here, most of the work actually done in the USA, some in China. Okay, these are the two major focus countries, and other countries Europe. But if you look at Africa, Asia, and also South America, not much, isn't it? We can see not much. Okay, the main reason due to fund. And this recent research study, they're finding that their main focus was actually on nitrogen. They found that they reported that the target for nitrogen, phosphorus, these are the nutrients. These are the top nutrients which is coming from the agriculture activities, from the fertilizers. Okay, and others like the number 3 is heavy metals, as I have mentioned, from the metal surfaces or also from the pavements, from the vehicles. These heavy metals are released because these heavy metals doesn't decay. Nitrogen, phosphorus, it can change its form. Okay, it can be uptake by the plants and also other aquatic flora and fauna. But the heavy metals are toxic to most of the organism to some extent. Okay, so they are remaining in the atmosphere once it is disturbed and available in the water. So these are the main focus of the research. So those who are interested in NPS pollution study, you can also look into this paper. Okay. Again, you see why I mentioned that non-process pollution is important for water resource management, isn't it? Because most of the study is actually done for the protection of the surface water resources. Okay. The number 2 is groundwater. So as we know, these two are actually our main water resource. Okay. Others studies are actually done on the wastewater, drinking water, and also seawater. So let us compare quickly the difference between point source and non-point source, which I have already mentioned, but let us look at the organized manner. Point source generally from man-made facilities like industry, houses, restaurants, workshop, those kind of facilities. On the other hand, non-point source from the all open surfaces, whether it's natural or it's man-made. Okay, depending on the cleanliness of the surface, different amount of pollution will be generated. On the other hand, point source actually is continuous or intermittent depending on the process. These days we have 24-hour industries, so in that case there can be continuous discharge of wastewater. Otherwise, it is generally intermittent. Even our houses, so we don't discharge wastewater continuously, isn't it? It's intermittent. Okay. Normally, there's a morning peak when we go to office or school. We take shower, we take breakfast, so there is some wastewater discharge. During noon, also there is people discharge water and also take shower, take lunch. So there is some water discharge. Otherwise, during midnight, maybe there's not much water discharge. So what I want to say here, point source actually can vary with time. On the other hand, non-point source generally generated during rain. If there is no rain for few days or few weeks, normally there will be no rain-induced or runoff-related pollution. Okay, same goes for the snow melt. Okay, so then with regards to the pollutant, with regards to pollutants, BOD, COD, these are the common pollutants generated from the point sources. On the other hand, suspended solids are more generated, like sediment. These are more generated from the non-point source, from the rainwater. Okay, COD, chemical oxygen demand, like all oxygen demanding materials, metals, fertilizers, pesticides. These are commonly generated from non-point source. So from here we can see, the type of pollutant generated from point source and non-point source are different. So that's why the treatment method also could be slightly different. Okay, it is not same. Whatever method we apply for point source pollution control or treatment, we cannot apply directly for the non-point source. Okay, because the nature of the pollutant is different. Typically, the pollutant concentration in the point source is high compared to the non-point source. Why? Because the amount of flow is small. On the other hand, for the non-point source, the amount of water actually flow is very high. Okay, so it gets diluted. Some pollutants actually get diluted. For example, ammonia. Ammonia mainly generated from, like our urine, from the wastewater, domestic wastewater, high ammonia is generated. Okay. On the other hand, in the nature, high ammonia is not available that much. Okay. So in that case, the concentration of ammonia generally high in point pollution sources, and ammonia is very low in non-point source pollution sources. And for the point source is confined, coming from certain facilities, man-made facilities. On the other hand, non-point source coming from all over the places, as I had mentioned. These are some typical data to justify my statement that certain pollutants are high in the point sources. Okay, these are the point sources, sewage. On the runoff, actually, other could be high. For example, metal, and also sometimes can be what do you call it, the TSS, and also other pollutants can be high. Okay, you can see TSS is sediment actually. Okay, sediment. Again, I'm showing in graph. Typically during a dry day, the conductivity of water, like the dissolved minerals, the TDS. If we take sample from the river, we can see that these pollutants are high. Okay, the yellow coming from the dry condition. On the other hand, the blue one coming from the rain condition. Okay, sediment, COD, these are high. Okay, turbidity, this could be high due to erosion. These are some real picture from my own source. Okay, during rain, this can carry lots of sediment, and as I said, when there is sediment, we can expect there are other pollutants also available. Okay, so if we look at the flow in a natural river, when there is dry condition, the flow is uniform, and also you can expect the concentration of the pollutant also uniform, isn't it? Normally like that. Okay, but when the flow varies, the concentration of the pollutant also varies. Initially, some pollutants can be high. During the high peak flow, some pollutant can be low because they get diluted. On the other hand, at the end of the flow, runoff, also certain pollutants can be low because there is not enough pollutant available on the surface, meaning that they are diluted, wash away, okay, wash away. So why I am showing this slide? Because to study the non-process pollution, we have to actually sample several times for the whole hydrograph. Because as I have mentioned, during the flow, certain pollutant can be high during the low flow. We call it first flush. On the other hand, like sediment, more sediment can be carried during the high flow because it has energy, more energy to erode and also carry the sediment with the flow. Okay. On the other hand, other pollutants can be low during the end of the runoff because due to continuous flow, the pollutants already wash away. Okay. So why I'm highlighting here? Because during the dry time, if I want to assess the quality of the water, I can take only 1 or 2 samples. We call it grab sample. Okay, we can take few samples to assess the quality of the water during non-rainy day. But during rain time, I have to take multiple samples to assess the total pollution load generated during the hydrograph or due to the runoff. So for non-process pollution study, there is one term frequently used called EMC, event mean concentration, meaning that during the rainfall, the pollutant concentration will vary. But then what concentration should I use for my calculation of pollution load? In that case, we take multiple samples and then we multiply with the flow and divide by the total volume of the runoff, we get the EMC values. That means there will be something like average concentration. Okay, but it is not just I take 3 samples and make arithmetic average or arithmetic mean. Not like that. We have to multiply with the flow. Okay, so this concept is called EMC, event mean concentration. And as you know that rain is not same every day. Sometimes there is small amount of rainfall, can be moderate amount of rainfall, can be heavy rainfall. So that is why we should take several samples, and after that we find out the EMC for each sample. Then we can average the EMC values of multiple events to calculate one average EMC for the purpose of calculating non-point source pollution. On the other hand, during dry day, only 1 or 2 graph samples should be good enough. So this indicates that to study non-point source pollution actually is tedious. It takes a lot of efforts and also a significant amount of money for proper assessment. Okay, only simple taking 1 graph sample will be misleading. Okay, it may be overestimated or underestimated depending on when we're taking sample. So this is discussed by this concept called polytograph. I've already mentioned. This is the hydrograph. Flow can vary during rain. On the other hand, concentration can be, for certain pollutants, can be uniform or whatever. But once we multiply with the flow, excuse me, so we can see the load becomes almost same as the hydrograph, because the flow is actually controlling the load when the concentration is almost uniform. Excuse me. So this is for one pollutant. For the other pollutant, it can be different, okay, vary like this. So what I'm trying to say, there can be variation of the pollution load, and that is why you have to take multiple samples, multiple events to get a considerable and acceptable value of pollution concentration due to runoff. This is real data. As you can see, and for the same event, same hydrograph, different pollutants has a different type of variation. Of course, most of the pollutant initially was high concentration. Why? Because we call it first flush. Just imagine, I'm explaining sometimes a little bit detail, assuming that maybe there are audience who are not from this environmental side, so they may have difficulties to understand. What is first flush? First flush is very effective for non-process pollution control. I'm sure you have realized that when the rain begins, the runoff is more polluted, isn't it? It carries a lot of debris. If I get the chance to give an example, if we wash any dirty cloth, initially, once we wash with the soap, initially water will be dirty, isn't it? If we continue washing, then gradually the water will be cleaner. Same happens to that runoff. When the rain starts, there are lots of dust and dirt available. So the initial flow will carry lots of high concentration of pollutant, generally, okay? Generally. Then after that, gradually they will be reduced. Why? Because the amount of availability of pollutants are reducing, okay? Except maybe, certain pollutants, for example, TSS, okay? Or maybe COD, okay? This may be high when the flow is significantly high, because these are related to particles. The particles will move when the flow is high. So what I'm trying to highlight here, this is the real data. Due to the variation of flow, the different pollutants will behave differently. That's why we have to take sample at different time of the flow. Only one sample will not give us, representative data. Okay, so that's why EMC is a very acceptable concept in non-process pollution control studies. Okay, event mean concentration. So this is the equation. As I said, we have to take multiple samples, we multiply with the flow and divide by the total flow, we get the EMC value. Okay. Okay, now we have understood that non-process pollution control is very important because it carries a significant amount of pollutants, especially with regards to pollution load, annual pollution load. So now to determine the pollution amount, we need to take samples, and it is not that easy to take sample for during the rain. Excuse me. Number one reason why, because safety is very important. During rain, most of us actually remain within the shelter, isn't it? In the room or in the office. We don't go outside. But actually the drains are drains become very ferocious. Depending on the location and amount of rain, the river flow or the drain flow can be very high velocity, okay? It can have a very high velocity. And if anybody accidentally fell into the drain or river, he or she may be washed away, and there are cases of death. Even in Malaysia, there was one case, the student passed away because he just fell into the drain during the sampling, and he couldn't stop himself. Although he was a swimmer, but it was very high velocity, and his body was recovered as a dead body in the big river. Okay, so that's why safety is very important. Okay, we should take full precaution while during sampling for the runoff. Okay, not only that, even during thunder, people may be struck by the thunder, so it's really risky to sample during rain condition. Okay, the other challenge is the rain. Sometimes we get ready because this non-poisonous pollution is not like a grab sample. As I said, we have to carry lots of equipments. Okay, some parameters has to be measured at site, isn't it? On-site parameters. So we have to carry a lot of things for the flow measurement, for the other measurements. So sometimes we can see that it's cloudy, most likely it will rain. But if we get ready with the location, we find that the rain actually happening other place. So we are actually losing our time. So catching rain is not so easy. Even the sampling location, we should be finding a suitable location. It is not so big or so small, so that it should be perfect. Okay. Again, number of samples is important. Normally, we take about 24 samples to cover the whole hydrograph, depending on the catchment size. Selection of pollutants also important. Which pollutant we should study? Okay, and also there is more variability in data. Even the same location, small rain, different data, medium rain, different data, heavy rain will be different data, isn't it? Even the catchment activity will affect the quality of the runoff. Even though the same amount of rainfall, but if the activity was different during the rainfall, the data will be different. So there are lots of challenges actually, and it's not an easy job. It's not just layman job, okay? And not forgetting the last point, which is high cost involved, okay? The more sample we take, more laboratory experiment we have to do, and it costs a lot of money. This is one real example when we, and these are the steps of doing the non-point source sampling, okay? We have to identify the catchment area. Catchment area means from where the water will come to the sampling location, okay? Meaning that this area not included actually here, because this area will discharge water to the other other outlet. Okay, this is a lake. This is a lake. Just now, remember I show one photograph. This is actually at this location. I'm sorry, it's far away. Yeah. Okay. This is the lake. Okay. This is the lake. All right. So we have to define the catchment so that we can calculate how much area, because later on we need additional information to do the calculation of pollution loading. It is good to have the drainage network. This study was quite detailed. Okay. So we need to know the catchment area and other hydrological properties. And usually we need sampling like this, sampler like this. This is called for graph sampler. And also we use automatic sampler because the rain can come anytime, isn't it? So this sampler is very costly, very, very costly. But the benefit is it can be programmed. When the rain will happen, then the runoff will start. Then the sampler can automatically take water into the samples, bottles like this, and it can sequentially fill up the bottles. From there, we understand which bottles are at the beginning of the sample and which bottles are at the end or other time. Okay, so this is the real project. Okay, and to activate the sampler, we have the rain gauge. When the rain starts, and after certain amount of rain, when the drain flow is significant enough, water rises, then the sampler will trigger. Okay, it will take the sample. So there is automation. Okay, possible. Okay, and this is another pipeline to collect the sample. So the water level sensor inside the drain, which will indicate when the water level rises, it will start taking sample, and this pipe will take water and fill in the bottle. I think I have already mentioned that normally we go for graph sample for point source, but not suitable for the non-poisson study. We will take continuous sample, okay, or maybe composite sample. Composite sample means in one bottle we can multiply, add 3 or 5 portions, or of the amount of water to reduce the number of samples. Okay, so I think these are the basic points I would like to skip here. And after collecting samples, we have to preserve properly. Otherwise, the data can be, the sample can be degraded and modified. Okay, so just to highlight that for any water quality study, sampling is important. Sampling procedure should be perfect, as good as possible. Sample preservation also should be proper, okay, according to the standard. And finally, the sample testing, okay, the calibrated equipments, the method should be acceptable. So these 3 elements are equally important. If one goes wrong, then it may give wrong information to the researcher. I think I would like to skip this, steps. This is a detailed method. What should be followed for a non-poisonous pollution sampling study, okay? These are the parameters we should monitor, okay? And normally what we do, initially we do not know which pollutant will be high, isn't it, in this catchment, in this river basin, okay? So normally we start with a large number of pollutants. Then after taking few samples, we find out that, okay, maybe certain pollutants are not critical, so we discard, okay? Then we can focus on the major pollutants. But, from the worldwide data, we can already know what are the typical pollutants for non-poisonous pollution. So basically, these are the most common pollutants beside the bacteria and pathogens, okay? So we can do literature review to minimize the cost of our non-poisonous pollution study, okay? So again, this is real data, real project, okay? If the catchment discharge, dry weather flow, meaning that wastewater from the point sources, we also have to study that pattern of the dry day flow, because that contributes the point source. Our objective to determine pollution from the non-point sources. So we have to subtract the flow and contribution from the point sources. That is why we have to study the dry day flow also. So as I said, a non-poisonous pollution study is not so easy. It requires a lot of efforts. Okay, again, the pollution varies with time, isn't it? So we have to conduct the study to determine the base level contaminants, okay? Meaning that during the non-rainy time, what is the contribution of flow? We have to determine. And during the rainy day, what will happen? This non-rainy flow also will be there, isn't it? From the domestic and other point sources. I hope my point is clear here. During the rain time, this pollution also will continue flow. So when it takes sample from the during rain time, it's actually a combination of point source and also runoff. So from there, we have to subtract this contribution from the point source to get the pollution load from the point sources. Sorry, non-point sources. Okay. So that's why you have to conduct study of the dry period also. Okay. So after having all this data, we can calculate the pollution loading from the point source and non-point source. So as you can see from here, the orange color is coming from the point sources. So you can see certain pollutants like TDS, BOD, total gel nitrogen, ammoniacal nitrogen, reactive phosphorus, nitrogen, all these things coming from the wastewater, most coming from the wastewater, isn't it? Organic wastewater, okay? Organic wastewater. So these pollutants are more generated from the point source. On the other hand, like the TSS, you see the solids. Solids also contain certain amount of volatile compounds, okay? Volatile suspended solids. The COD, chemical oxygen demand, and the other metals. These are generated from non-point source pollution. But again, just to remind you that this is true for this catchment, this study that we have conducted. This could be different scenario for other catchment. Even within the same region, different location could be different data. Okay, that is why it is recommended to have a large number of study and to get some data bank for the average data. Otherwise, it will be costly to conduct the study for each catchment will be very costly and time consuming. Okay, not feasible. So it is advisable to have national database. Like America and other countries, they have their national database. They conduct study in many parts of the country and they have make some average, which is good enough for us to deal with. So I believe that all my slides I have shown just now convinced us that water resource impairing pollutants are also discharged from non-process pollution due to the storm runoff. Okay. And of course, this the types and the amounts of pollutants can be different in different areas. That's why it is good to have, some database or conduct some study for the proper management of water resources. So it is always recommended to have site-specific data, okay? If not new study, but at least the data should be there. Okay. Now the question could be, then what should we do? How can we control the non-process pollution? Isn't it? This is a very obvious question. So as I have mentioned, there are treatment methods available, but those are not like wastewater treatment. Generally, we more rely on the natural based process. For example, infiltration facilities. Okay, if we allow the water to infiltrate, then the water will be naturally filtered by the soil particle, isn't it? Okay, or maybe sand. We put sand and other facilities, other media, so the water will be filtered. The urban or aggregated runoff pollution, whatever pollution we have, it can be filtered. Okay, and it can also recharge the groundwater. So this is one of the common method used for runoff treatment. Normally, these treatment facilities, we call them base management practice, BMPs, okay, base management practice. Excuse me. Another type of method used is bioretention facilities. Basically, this is this kind of infiltration facilities, but we have plants on the top, grass and other plants. So these plants also can, extract or abstract nutrients, and they can filter the pollutants. Okay. The third type of traps are called gross pollutant trap. Normally to trap the debris, floatables, plastic, and whatnot. Okay, so basically this is a chamber or small basin like that. There is a screen which will filter or separate the solid particles. So usually we have to clean this trash of after each event. Okay, otherwise they will be blocked and it will be overflow. So I'm not going to detail on this facility, just to let you know that there are methods available to control the non-process pollution. Swell is one of the method. Normally in the urban areas, we go for concrete drain, isn't it? For efficient drainage system. But according to new concept, this kind of natural system is much better. It will improve the runoff quality and also will allow infiltration of the rainwater. So this is good. Actually, the big facilities that we rely on is the pond, water quality pond, okay, and also the wetlands. These are the important facilities which can really significantly reduce the non-process pollution. Okay, so wet pond and also wetlands are actually very effective in controlling non-process pollution. So I'm almost at the end of my presentation. So I'd like to conclude that the controlling pollution from the non-process pollution is important. Okay, there's no doubt. Research have been done in the developed countries. They have found that controlling point source is not good enough. Okay, but the control of non-process pollution requires special procedures compared to those required for conventional water samplings, like for point source. Okay, like industrial pollution and other wastewater pollution. It is different from the non-process pollution. As I have explained to you, for non-process pollution, we have to sample the whole hydrograph. Otherwise, the data will be misleading. So I believe that the tips provided will help to overcome the challenges faced during the non-process pollution study. And if any further discussion required, I'll be very happy to share with all my other experiences, because I didn't go that detail about the sampling, testing, and also calculation of the non-process pollution. And also I didn't focus much on the control methods, control techniques of the non-process pollution. Okay, but however, water resource management, ignoring the importance of non-process pollution control, would be an unsustainable way of managing the water pollution. I'm sure that countries like Asian countries and also developing countries, we know our challenges in managing the water resources, because the water resources are day by day getting polluted. Okay, in the past maybe we could get a lot of fish from the rivers. Now the rivers are so much polluted due to various reasons that fish is not available. Even some of the river water is not suitable for our irrigation or other applications. Okay, so I'd like to acknowledge the cooperation for many other parties involved in this presentation. Also, I acknowledge that much of the documents are actually taken from the internet sources. And with that, I'd like to thank you for your patience. Thank you very much. Assalamu alaikum.
Thank you, sir. Thank you for your wonderful session. So now the participants, the chat box is open for your queries. You can post your questions in the chat box. Hello participants, you can post your queries in the chat box. Query session is started just now. We have 20 minutes for question and answer. Participants, please, you can post your queries in chat box.
If it takes time to type, somebody can also post question audio.
Sir,
Unmute.
sir, because of the huge audience, we have muted audio
Oh,
and video. Sir. So that's the
all
reason.
right. All right.
Yeah,
Okay.
they will post in the chat box so that you
Understood.
can clarify. Yeah, you can clarify the doubts. It was very informative session, sir. Thank you once again.
I'm afraid it could be a new topic to many of our colleagues. But anyway, let us feel free to ask question.
Yes, sir. They are just now the chat box open, sir. They'll post the queries.
I think thank you for your thank you notes. We are waiting for a question. Okay. It was my honor to be with you, all of you. So it's okay.
Sir,
Enough things.
one question is arrived, sir. Conducting NPC research, is there possible to simulate in CFD?
CFD is, are you talking about computational fluid dynamics?
So just he abbreviated.
Yes. So I believe maybe, what is the question? I couldn't see.
1626. I mean the Indian timing 1626. Vivek asked the question, sir. Sir, conducting NPC research, is there possible? Again, I'm copy pasting, sir. Just look
Okay.
at it.
Yeah. Yeah. I saw it. Okay. Okay. I believe the CFD is computational fluid dynamics. So in that case, if there are water quality parameters like sediment discharge, yes, it can be done. But in that case, we must have a lot of data, to calibrate the model, and after that we can simulate. So yes, it can be done for certain pollutants. Okay. So that is my answer. I think the question is very specific, and the answer also
Yeah.
very to the point. Okay, it can be
Yes.
done depending on the pollutant.
Sir, another question arrived, sir. In India, we are detecting antibiotic resistance bacteria in canals and rivers. What is the Malaysian experience? This is attributed to the increasing usage of medicine since COVID-19.
Yeah, I think that is true in all over the country because, as I said, pollutants are unlimited. Once we produce new product, the general definition of pollutant actually anything, either good or bad. Even it's like another example, vitamin. Vitamin is good for health, isn't it? But if we take too much, it is harmful. Same definition goes for the pollutant. Even the nitrogen, phosphorus, essential for plants and also other living beings. But if it is too much in the water, it becomes a pollutant. So that's why whatever element is available more than the acceptable limit, it becomes a pollutant. So as you said, the antibiotics and also other drugs actually becoming a concern all over the country. Even the plastic, microplastics. Now there are new types of pollutants are emerging. Okay, so this is one new area where you can focus also in your locality, emerging pollutants.
One more question arrives, sir. Dr. K.
Yes.
Muhammad. How can agricultural runoff contribute to non-point source pollution, and what sustainable practices can be implemented to reduce this impact?
Okay, so the process of generating non-porous pollution is the same. I mean, once the area is exposed to rainwater or snow melt, then it will generate non-porous pollution. So as you said, but I don't know why you asked a question that how can agriculture runoff contribute to non-porous pollution? Definitely it contributes. Once it goes to the, either river or goes to the groundwater, it will contribute to the non-porous pollution. Okay. And the sustainable practice actually, as I said, we should capture the runoff. Especially for agriculture runoff, it carries a lot of nutrients, a lot of fertilizers and other things. If we can recycle the water, that is much more beneficial. But for that purpose, we must have land. That means we capture the runoff and we recycle it. In that case, we can reduce the amount of fertilizer. We can reduce the amount of other nutrients by recycling this agriculture runoff. Okay, so this is one of the easy way to to control the runoff pollution from agriculture areas. Okay. Generally, for any runoff pollution control, there should be a retaining structure. or retention structure like pond, wetland. We hold the water there, okay? And the best way, if we can recycle it back, especially for agriculture runoff. All right. What are the primary source of non-poisonous pollution? If you say number one could be agriculture areas, number two could be the construction sites, because these are exposed to rainwater, isn't it? But again, the agriculture side depends on the season. If it is at the beginning of the crop cultivation, when we disturb the soil, then the runoff pollution will be more compared to when the field is already matured. The field is covered by the crop. Once the field is covered with the crop, maybe there will be less detachment of the erosion and other particles, right? So it depends on the condition of the agricultural land. Okay. So the primary sources already mentioned during presentation: agriculture, construction site, even runoff, even the forest, natural forests also produce runoff pollution when there is rain, depending on the amount of rain, okay? Are there regulations in Malaysia that mandate the reuse of treated sewage for flushing? Not yet. It's not compulsory yet. Not yet. But rainwater harvesting is used in or encouraged in many places. Okay, rainwater harvesting, because Malaysia receives about can you imagine 2.5 meter of water every year. The annual rainfall on average is 2,500 millimeter. Okay, in the West Malaysia, Peninsular Malaysia. In the East Malaysia, it is more than that, about close to 4,000 millimeter. Okay, Sabah Sarawak. All right. So the reuse of sewage is still not used. Normally, the wastewater is treated and discharged into the river. But recently, they have started to reuse this treated water, which is good quality, very good quality, for landscape purposes. Okay, for the landscape, not for crop production, for the gardening and landscape, urban city landscape purpose, which is beneficial because it contains nutrient, right? It contains nitrogen compounds and phosphorus, which is very nutritious for the plants. Okay, so it is not used as irrigation, okay? But as I said, rainwater harvesting is recommended, okay? Many offices, they have rainwater harvesting. Okay, next question, Mr. Narendra Kumar. What role does urbanization play in increasing non-poisonous pollution? Okay, and what management strategies? Actually, management strategies for non-poisonous pollution control is almost similar for any land use, okay? Agriculture, urban, commercial, institutional. We need to hold the water, let the pollutants settle down, and the clean water will be released slowly, okay? This is the basic procedure. So it is same. And in Malaysia, they have actually they have urban stormwater management manual. It's a detailed manual to control the runoff flow for flood protection, and also to control the runoff pollution by providing all these facilities. If those components are not included in the project, normally the project is not approved by the government. So can you imagine, for any approval housing project, development project, they must have these facilities. Okay, so this is a good move. During rainy season, this is Vivek question again. During rainy season in our areas, okay, river in Western Gate silent, valley, is that impact downstream? Okay, of course, when the runoff carries lots of sediment, normally dam, it will actually capture the sediment, isn't it? So there will be accumulation of sand inside the reservoir. So the reservoir capacity will be reduced, okay, day by day. So this is one of the important issues for the operation of dam. Maybe after 20-30 years, the storage capacity will be reduced, okay? So in that case, water resource also will be hampered. Okay, so yes, the runoff from the forest also can be affected depending on the condition of the forest. Sometimes there are forests which is logged regularly, isn't it? So logging forest will have more impact compared to virgin forest or primary forest. Okay, so any logging effect will generate huge amount of sediment, and that will affect the the downstream river system. Okay, I think Okay, Mona, are you referring to Singapore, right? Singapore, yes, Singapore they are using, because Singapore is a small island. There is not much, river there, not many rivers there. Whatever rainfall happens, rainfall amount is almost same as Malaysia, but not having enough catchment, they cannot store the water. Okay, so actually they have impoundment, artificial impoundment. They hold the water in the river estuary, okay, by embankment, and they use this water. Okay, besides the sewage water. Yes, Singapore use sewage water for treatment and for drinking, but Malaysia no. Okay, of course, for any environmental issues, community awareness is very important. Okay, for example, for non-poisonous pollution, like the contractors, they must be aware about their activity. If they leave the soil surface open, for a long time, normally they clear the land a few months ahead, isn't it? Clear the whole land, and gradually they develop the area. So that is not a good practice. The good practice is to clear the land by package, patches by patches. Small area first. Okay, once this foundation is done, then go for the next area, like that. But that's why the awareness is very important. Okay, for any environmental pollution control, awareness is very important. Even not only the contractors. If I have a bangla house, or if I have an agricultural plot, okay, if I don't manage it properly, if I keep my construction material like sand and other things on the road, when there is rain, it will carry sediment, isn't it? Some of the sand will be washed away. So everybody has to play their own role to reduce the non-process pollution control. If I love gardening, then I should not disturb the soil and leave it open to rainfall, which will generate lots of pollution. Okay, so awareness is very important. Okay, how can we raise public awareness? All right, through education. Every time there should be advertised in the newspaper, through digital and printed media. Okay, and also there can be roadshow. The authority can go and show them videos how the pollution are generated. Please go through the internet. There are a lot of wonderful videos for people to understand that how the rain can generate lots of pollution due to our ignorance. Okay, and actually, as I said, during rain time, we are confined in the office and the house and the room, isn't it? We don't see what is happening. So we can see during rain, lots of pollution actually flowing through the river. River become dirty. Okay. So I think awareness is very important. And you can use the local media and printed media for increasing the awareness. Okay. How can Mr. Akram question? How can watershed management practices be optimized to prevent and reduce? All right. All right. So as I said, if the catchment is well managed, then the amount of pollution will be reduced significantly. Because the rainwater we cannot control, isn't it? Whatever rain happens, it will happen. What we can do is properly maintaining our areas. Okay, this is called housekeeping. Another term is called housekeeping. If we maintain our areas clean, if we don't throw rubbish here and there, if we cover our solid waste properly so that the rainwater cannot get access, if we maintain our garden properly, okay, then it will be easy to reduce the pollution and manage our water source properly. So catchment management is very important. Okay, and that is why actually there is another approach called integrated catchment management, ICM. Okay, integrated catchment management is very important. Otherwise, what will happen? One authority will blame the another authority. Okay, the Department of Environment will blame the other, say, agriculture department, because this is due to their pollution. The other, one department will blame the other one. This will happen. Blame game will happen. So there should be integration among the all authorities and stakeholders. All the stakeholders should work together. And for any environmental management, actually, good intention is important. We have to understand that if the environment is polluted, our next generation life will be jeopardized. Okay, will be compromised. So once we understand, then inshallah we'll take care. Okay, I think I have already mentioned the challenges are same, Mr. Narendra Kumar. Okay, first thing, we have to try to make our drainage system as natural as possible so that more water can infiltrate. If more water can infiltrate, actually less pollution will be generated, okay, to the rivers. Because once the water infiltrates to the soil, actually it gets purified. That is why when we take water through tube well or groundwater, it is almost clean, isn't it? We may have to remove some of the dissolved minerals like iron, manganese, magnesium through chemical coagulation. But generally, those water is usable, okay? Generally usable. So the challenges are very common, as I have mentioned. Those are same as the developing country and developed countries. In the developed countries, maybe their surroundings are very clean, okay? They have less pollution, but they are also using lots of other chemical, materials for their daily activities. So in that case, they have different nature of pollution. In our countries, we have different types of pollution. Okay. Okay, Mona, the question is wear and tear of brakes. Yes. Of course, any particle available on the surface is a source of non-process pollution. Okay, either from the brake or rubber tire, or even once we walk, our shoe also get wear and tear, isn't it? So whatever happens, even the pavement, bituminous pavement, once we surface, it is smooth, isn't it? But gradually it becomes rough. Why? Because the fine particles get detached. Also, is a source of pollution. The road marking, after a few months, few years, it disappears, isn't it? Also source of pollution. Okay, so whatever available on the road surface, exposed surface, whether it's natural ground or pavement, it is a source of pollution actually. Okay. So actually, best management practice means in the Western countries, developed countries, they have conducted a lot of studies how to capture the pollutants. So they have found their like infiltration facilities, bioremediation facilities, natural drainage. They actually help reduce the pollutants, especially sediment. They can capture the sediments. Okay, and so once we have wetland, it can reduce the nutrients. Okay, so okay, the question is what role? They actually either they remove the pollutants by physical filtering process like adsorption, okay, or filtering, or some of the pollutants like dissolved pollutants, it can be absorbed by the plants. Like some of the heavy metals, actually some plants can absorb, like water hyacinth. Water hyacinth and many other aquatic plants, they can absorb the nutrients like phosphorus, nitrogen, and even the heavy metals, they can actually absorb. They can accumulate in their body, okay? Any particular possible solution for soil runoff sediment into river stream? Okay, one of the common thing we can do, it is called sediment fence. For example, if I have any plot, I can surround that area plot by a geotextile, geotextile, those kind of fabric or filter. Okay, if we surround, then the actually maybe 80% or 90% of the soil particles will be retained there. So this is one of the easy method to reduce the sediment problem. Okay, from any construction side or any side, even agricultural side, we can have sediment fence. So please take note of these terms. Then later on you can Google because we don't have much time. Okay. How can urban planning strategies mitigate non-conscious pollution? Yes, good question. Actually, once we are serious about controlling non-process pollution, it should start from the beginning of the development, not after the development. You see, of course, when the development is done already, there is not much room for us to, build another facility, isn't it? Like pond or wetland is difficult unless we do small facilities like GPT and infiltration trench, infiltration fence. Those can be done, but the big structures are not possible. That's why the best practice actually to have proper planning at the beginning. For example, during planning, we can have natural drainage if possible. If the area is sufficient, we can have natural drainage because natural drainage require more area compared to concrete drain, isn't it? Because natural drain, the water flows slowly. Okay, so if you have all this component that I have recommended during the planning purpose, that is the best way of controlling non-process pollution. Okay, thank you for the question. Yes, I think yes, asbestos is not only used in brakes, also some of the roof material people use still asbestos because these are cheap. So it could be a concern, when there is what do you call it, hot season and rainy season. So asbestos can be released to the atmosphere and it can be carried by the rainwater. Okay, until now, these are the questions. If anybody has any more question.
Participants, if you have any questions, please post in the chat box.
or if I need to clarify any other terms or topics. So as I have mentioned, this topic actually is still new in the developing countries. If any of the colleagues or members are interested to conduct research on non-process pollution, we can have further collaboration, further discussion for our clear understanding, okay? And also for planning purpose. You can do your project over there, but you can discuss, digitally, we can discuss furthermore to conduct the research properly.
Okay, sir. Thank you for nice question. So someone again had one question, sir. Mauna, any regulation on of use of personal care and pharmaceutical products in Mumbai? They are the emerging contaminants.
Yeah, actually, it depends on our own. Okay, in the old days, okay, in the old days, people didn't use so many products, isn't it? Still, they were happy. Still, they are healthy. Still, they are beautiful. So now it is up to us. Do we really need to waste our money and cause more environmental pollution, or we should be happy with the minimum? Okay, this depends on us. But in reality, there's not much regulation because it relates to the industrialization, isn't it? It relates to the economy and business. So there will be lots of hue and cry, So if there's regulation on banning certain products, of course, if it is really harmful, definitely government does that. Okay, if any product got some harmful elements, especially with regards to health concern, then government actually ban those items. Okay, but with regards to discharge into the wastewater, not much government can do. Okay, because this is very personal, very private, isn't it? Okay. Not only about the over the counter available materials. Sometimes the people have herbal kind of products. I mean non traditional products. Those also may carry different things. So this is really difficult to control. Okay.
Sir, sorry for interruption. Just for 2 minutes, the participants, please open your cameras so that we can have a photo session as ATAL FDP requirement along with speaker. All participants, please open your cameras, webcams.
I would like to thank you again for your opportunity and giving me a chance to share whatever I have experienced.
It's our pleasure, sir, to have you. So it was nice and wonderful session. So just for 2 to 3 minutes more, sir. Just we have one photograph as an ATAL FDP requirement. Participants, please open your webcam. Hello, thank you very much, sir, again. So participants, before going to start another session, means last session, 13th session, our coordinator have some points regarding your online test. So we will guide you on that. So Dr. Imdadullah, sir, am I audible?
Yes, sir, it is audible.
Yes, sir, you can take. Sir, Dr. Abdullah, sir, you can sign off, sir.
Okay, thank you very much.
Thanks.
And if anybody is interested to any collaboration or discuss, please share my email address, or you can search my name. You can search my name in IIM, so you can find out.
Yeah, okay. Yeah, sure, sir.
Okay.
Thank you once again.
Thank
Okay,
you, sir.
thank you very much.
Sorry, 6:40. Last section ends at 6:30. You know very well. After 6:30, we are giving 10 minutes time for preparation of personal details of participants. That is the PID, all this which you entered in your participant portal, email ID, everything you have to keep ready. After that, 6:40 to 7:20, we are giving 40 minutes time. 6:20 to 7. Sorry, 6:40 to 7:30, we are giving 40 minutes time. Within this 40 minutes time, you have to enter your personal details, and 30 questions is there. The section will be the online test will be on Google Form. The first sheet will be for appear on your personal details, participant details. Next sheet will be on 30 questions. So 40 minutes for your online test.
Hello, participants. If you have any queries, you can post in the chat box. Chat box is open regarding your online test and all.
Online test starts at 6:40 and it ends 7:20.
Welcome you to the session, sir. So after the introduction part, you can start the session, sir. So participants, the session is going to start now. Our today's last session speaker is Dr. Sheikh Mohammad Rasul, Associate Professor and Head of the Department of ECE, Lord's Institute of Engineering and Technology. Dr. Sheikh Mohammad Rasul is an accomplished Associate Professor and the Head of the Department of Electronics and Communication Engineering at Lord's Institute of Engineering and Technology with a PhD in Wireless Sensor Network. Dr. Rasul has made significant contributions to both teaching and research in the field of electronics and communications. He brings over 12 years of teaching experience and has been an active researcher, publishing more than 20 papers in international and national journals and conferences. Dr. Rasul is also an evaluator for the Institution Innovation Council and a reviewer for ASTEGA Scoopus Q3 Journal. His expertise and reputation in the academic community are further demonstrated by his role on the editorial board of the International Journal of Mechanical Engineering and Computing, IJMEC. In addition to his academic achievements, Dr. Rasul has been recognized for his leadership and contributions. He was invited as a session chair at the national conference held at Theme College of Engineering, Mumbai University. He also received the Best Paper Award at the ICMLDA 2020 organized by SV University, Tirupati. Dr. Rasul has written a book and has one patent to his name, further demonstrating his innovation and commitment to the field. He holds a lifetime membership with the Indian Society of Technical Education, ISTE, and has actively participated in numerous workshops and FDPs at prestigious institutions such as IITs, NITs, and other reputed organizations. He is also a Board of Studies BOS member at Osmania University, contributing to the curriculum development and academic advancement in his field. Dr. Rasul has academic contributions, leadership roles, and ongoing commitment to innovation continue to enrich the field of electronics and communication engineering. So with this, I welcome you, sir, for the session. Now I'm handovering the session to you. You can start the session, sir.
Thank you, Mr. Muhammad Jalal, sir, for with your introduction about me. So I will welcome you all participants for this wonderful ATAL FDP. The entire week, I mean, you have actively participated and then you listened the expertise in this area. So now this is our last session. I hope that I'll make you to understand the things what we are going to discuss here. So let me share my PPT here. Yeah, myself, Dr. Sheikh Mohammad Rasul, Associate Professor and HOD of Lord's Institute of Engineering and Technology, Hyderabad. Today, I'll be discussing the critical role of renewable energy in energy efficient buildings and how it contribute to a sustainable future. Okay, let's start with what are energy efficient buildings here. So, and why, I mean, it is more important here. Rising energy cost and depleting natural resources and environmental degradation are critical issues that need addressing. So, as we all know that, I mean, the problems which we are, I mean, facing nowadays in these areas, so we have to address very much needed. So with the energy efficient buildings is required here, and India can significantly reduce greenhouse gas emission, and it improves energy security and reduce the dependency of fossil fuels. So we have a renewable energy sources are available. So these renewable energy sources are very clean energy, and they have a zero carbon footprint, but they can be called green energies since they come from a natural sources. So what are the benefits of energy efficient in buildings? So energy efficient buildings are designed to reduce energy consumption while maintaining comfort, productivity and functionality. In India, where electricity demands are escalating, buildings account for nearly 40% of total energy use. The static emphasizes the need for energy efficient in building design by implementing energy saving techniques and integrating renewable energy sources we can create a more sustainable and environmentally friendly built environment. So these are the some advantages where you can see here in the slide. So first one is here reduction operational cost. The second one is enhanced comfort, and third one is environmental impact, and the fourth one is increased property value. So let us go in detail of these four advantages of energy efficient buildings. So the first one is here reduced operational cost. So where lower energy consumption so directly translates into decreased electricity bills. As we all know that, I mean, how much of electricity we used, so that much of a bill will be generated, so that we have to pay to the, electricity board. So anyhow, so we have to reduce this. And the second one is here enhanced comfort, where the energy efficient buildings maintain better indoor air quality and temperature control. So these are the enhancement comforts are where we have to focus in these areas. And now come to the third one, which is environmental impact. So as we all know that, so buildings reduces, these buildings like environmental impact. The problem we are facing here, this it can be, if you have a environmental impact, so it reduces CO2 emission, okay, and helping India meet its sustainability goals. So as we all know that, we have a sustainable goals are there, which is around 17 sustainable development goals are there. So which we have to focus all these areas in upcoming days. And the last one is here increased property value. Anyhow, so if the properties with the energy efficient features can boost the market value of real estate properties. So you know that very well how the market value will be depends upon the things here. Now coming to the role of renewable energy in energy efficient buildings here. So what are the renewable energies are available? Okay, so like we have a solar energy and wind power is there. So these are the most energies which are available, okay, which is a free of cost. We have to we can get from the natural, these are the natural resources. The first one is this is a solar energy. So it is a major source of renewable energy, sustainable energy. So it is very efficient, and so it is a resilient buildings must include solar energy in their design. So in recent years, solar energy has gained popularity as a renewable energy sources, and you have, you might have know this this point. Some countries they have adopted this. Uh, generating the energy from solar. So where the entire villages are opting this technology. So where they are reducing the all the problems which you are facing while using the other resources. So these are the one of the beautiful renewable resources. Okay. So now, so in recent years, with this solar energy has gained popularity as a renewable energy source, and it incorporation into building designs. Yes, yeah, it is most important thing. So nowadays, in the construction field, big high-rise buildings, people are using this solar energy. These panels and all they are installing on the at the roof. Okay, now because of this, we can easily generate the solar energy. This power electricity here. So that electricity which is generating here through this solar energy, which can be useful for the home appliances and for our home needs. And this solar energy is one of the most widely adopted and yes, transforming renewable sources in sustainable building design. Okay, so let us move to the how these solar panels will work. So because we should know that how these solar panels will work, how much energy it will be produced here, so whether it can be useful or not. And as you all know that because we are in India, so we have not seen the most of this solar energy, these solar panels. So nowadays we are seeing all those things. So our government of India also giving the good incentives to installing these solar panels at home at homes and even for business purposes also. Anyhow I'll go through that those things in our upcoming slides. Now, so look at this here in this slide. You can see, so this is the solar panel. So where, I mean, it will be installed at the roof or where the sunlight is visible clearly. So in those places, I mean, we'll keep these solar panels. Okay, and you can see this here. This is a solar. I mean, generally, as we know that, I mean, solar will radiate the energy. So which is light from the sun is made up of the, I mean, tiny particles, which is called photons. The energy which is having the sun is a photon energy. So this photon energy, I mean, will be falling on the, I mean, this solar cells. So look at it here in this, I mean, second. So in this side, the picture is given here, which is a photons hit the solar cell panel, knocking electrons free of the silicon atoms within the solar cell. So generally, this is a one type of PN junction diode. So p-type material and n-type material will be, I mean, combined here, then will form a PN junction diode. But in a normal PN junction diode and this solar panel, it is somewhat different. Okay, now, I mean, these two are not same. So when it comes to the, I mean, working condition, actually this PN junction diode will cover with the a transparent glass where, I mean, it gives the travel the sunlight into the onto the, I mean, material on n-type material. Okay, generally these p-type material and n-type material will be, I mean, formed by using the, I mean, with the pentavalent atoms and then this trivalent atoms, which can be formed p-type material and n-type materials. Okay, then we made a solar cells here. Then coming to here, look at this, I mean, the third one, which is these. So what will happen here when these, I mean, two PN junction, I mean, the p-type material and n-type material will be, I mean, sandwiched here. Actually, it will be, I mean, combined together here. Then immediately there will be a potential barrier will be formed. So n-type material will have a majority carrier, which is electrons, and this p-type material will have a holes, majority carriers, and these, I mean, holes and electrons will be attracted towards the junction. Then it will be, I mean, form a junction here where the, I mean, electrons cannot move easily from n-type to p-type material here. So then what will happen here when the, I mean, solar sunlight will be falling on the material, then immediately these electrons will try to, I mean, move through this, I mean, p-type material, but due to the this potential barrier, so it cannot be possible to move easily here. Then the other source is there. It means that the connection here for the solar cell, so it is, I mean, so the electrons will start flowing through the, I mean, another side. Then it will be through flowing the electrons is nothing but the electricity. Okay, so in this way the electricity will be generated here. So here, look at this in the third point where these loose electrons are now free to move. So majority carriers are in the, I mean, n-type material or electrons. I mean, these electrons will start, I mean, moving through the another side, so that, I mean, electricity will generated here. So it creates the electric current from the positive and negative charges now present. I mean, these, I mean, they have passed through the layers of the solar cells here. So each and every cell, see, actually this is not the complete one cell here. So this is a entire, I mean, n number of, I mean, cells are combined here, because each and every cell will generate the 0.5 volts, 0.5 volts will generate a single cell. So now, so look at it here in this solar panel. So you can see n number of, I mean, cells are connected together here, so that it will be combined in a series connection. So then the electricity will be generated, which is how much voltage is generating. So that is depends upon the number of cells we are connected here. Now look at this in here, the electric current will flows through the, I mean, edge of the panel. That now I told you that, I mean, there is no possibility from electrons moved from n-type to p-type material. Then it starts from, I mean, flowing through this, I mean, okay. So in this direction, so the edge of the panel into the conductive wire, I mean, we are using here, so which leads to the inverter here. So as we all know that, I mean, now see, actually we can use this solar cell directly also. See, but the problem is here while using this solar cell, so it will work only in the daytime. Okay, so when it comes to the night time, so this solar cell will not be, I mean, generate the electricity here, because it requires the sun, okay, in all the time. So but as you know that, I mean, in day night, so this 24/7 this solar cell will not be work out. There is a, I mean, one kind of, I mean, possibility is there. So to utilize this solar cell can be easily, I mean, store in this energy, that is electricity which is generating by the solar cell, which can be stored in the batteries. Okay, for home appliances, I mean, as we know that, I mean, so many people are having this, I mean, solar panels at their rooftop. Then it is converting into the energy which is electricity. Then it can be stored in the batteries. Look at it here, the inverter. I mean, after this, I mean, the energy which is stored in a batteries, this is in the form of DC. DC is nothing but direct current here. So this direct current will be, I mean, stored here. Then after that, so now for our home appliances, we need AC. So that is alternating current is required here. So we have to convert this DC to AC. So that we have to use one inverter circuit. So this inverter circuit which can convert DC to AC here. Okay, so this inverter, so which converts the DC into AC. So then it will be provide the power here. Then after that, if you have I mean, n number of cells, I mean, these panels we have, so we can use for the home appliance, home needs all, as well as the industrial purpose also we can use. More number of, I mean, panels we have, so more number of electricity will be generated. So we can sell this electricity also for as a, I mean, commercial. Okay. Now, so the next, I mean, second renewable energy sources. Anyhow, we'll move further also about the solar cell. Now I'm giving the brief about the wind energy. So as we know that, I mean, wind energy is also a one of the resources, I mean, natural resources which have a wind turbines, and though less common in urban areas, can be a powerful renewable resources. So especially in regions which consist wind patterns. Actually, everywhere we cannot, I mean, install this wind energy, I mean, this wind turbines. So this we can install in only, I mean, where the air is, I mean, coming more like at hill stations and coastal areas. Most of the times, I mean, we have seen that this kind of, I mean, wind turbines at coastal areas, as well as, I mean, where the, I mean, there's hill stations. Okay. And then when it is used in a combination of the, I mean, with the solar energy and wind power, can significantly reduce it. So building's dependency on grid electricity generally. So I wanted to show one, I mean, high-rise building which using this wind turbines also, but I didn't get that picture. But it is, I have seen that one big building, so where this wind turbines are installed at the top of the, I mean, building. So when this, I mean, turbines will start moving, okay, so because of the air, then it will start, I mean, generating the electricity, which can be useful for the entire building up to some level. So we cannot say that, I mean, it can be useful for the entire building, for all the, I mean, appliances and all, but up to some level we can, I mean, utilize this, I mean, electricity. Okay. Now another, I mean, resources is there, which is a biomass energy. So where, I mean, derived for the organic material like plant waste and animal manure, and in another renewable energy resources, this one. Okay. And this energy can be used for heating or producing electricity. Yeah, this is another, I mean, type of natural resources, I mean, which can use to generate the electricity, particularly in rural or semi-urban regions. So making a viable and alternative in areas. And now coming to the integration of this renewable energy into the building designs here. So incorporating this renewable energy into the design of energy efficient building is not just a trend, it is a necessity, because we have to get the energy, that is electricity, from these renewable energy sources. So by adopting this, I mean, holistic approach, I mean, to building designs anyhow, so this we have will come here. Okay, anyhow, so the engineers, I mean, when you are to, I mean, design a, I mean, building structures, okay, so we have to see that, I mean, where we can, I mean, install this kind of, I mean, resources for our building purposes. Okay. And now coming to this, I mean, so installing the solar panels, okay, so on roof of the, I mean, building, so which is, I mean, mounting these are the panels are increasingly common in both residential and commercial buildings. So generally there is a two kind of, I mean, applications are there for these solar panels. One is residential and another one is commercial buildings. Okay, so residential purpose, the, I mean, the electricity which you are using, so it is, I mean, not much more, I mean, is required. So when you install some solar panels on a roof of the buildings, so it will be, I mean, very much useful for us to utilize the electricity for our home appliances, home needs. So it will be, I mean, much benefited. And next one is here commercial buildings also, where we have a high-rise buildings are there. So in those high-rise buildings, easily, I mean, install these solar panels. So then it can be useful in a, I mean, for commercial buildings also. Then coming to the solar, I mean, water heating systems. So nowadays, I mean, these is a very much, I mean, popular. All, people are using these systems can effectively replace electric water heaters. So naturally, I mean, we can heat the water, I mean, by using this solar water heating systems. Now coming to the designing with the passive energy techniques here. So the, I mean, in a orientation of the buildings, window placements and the use of natural ventilation and further enhance so energy savings. So these are all, I mean, so while designing the, I mean, these techniques, we have to take care of this. Now coming to the next one, which is the government of India. So our Honorable Prime Minister Narendra Modi on February 15th, 2024. So there is a one Yojana is there, which is a scheme is there, which is Muft Bijli Yojana scheme. So government launched on February 15th, 2024. Now here you can see that the possibilities, I mean, the facilities providing by the government of India. So with the average monthly electricity consumption, that is, this is the, I mean, area, I mean, this is the range of electricity which you are using for our home appliances, I mean, home needs. So which is 0 to 150 units. So which is around how much the solar plant required here, which is 1 to 2 kilowatts. I mean, generation is required to, I mean, complete this energy, okay, electricity which is required here. So the subsidy providing by the government of India, which is 30,000 to 60,000 rupees. So we can easily apply, I mean, that for our home needs. If you are ready for this, I mean, we can use this, I mean, facility from the government of India. Then if the units of electricity is more from 150 to 300 units, okay, per monthly, then you have to install the solar plants, which is around 2 to 3 kilowatts. Okay, so this can be designed, actually we have to design in such a way that which can provide which can produce 2 to 3 kilowatts. Okay, so then the subsidy from the government, which is 60,000 to 78,000 rupees providing here. So the next one is here, which is more than 300 units. So more than 300 units if it is required for monthly. So for this we have to install, I mean, solar plant capacity. So whichever the solar plant we are installing on a roof, okay, rooftop, so it should be more than 3 kilowatts. It should be generated, I mean, this much of, I mean, 3 kilowatts, I mean, electricity, it has to be generated. Then the subsidy, which is, I mean, support from the government of India, which is around 78,000 rupees. Now coming to the example of, I mean, this solar energy, I mean, this solar plant, so which is very much, I mean, using nowadays. So I want you people just see this, I mean, picture. So can anyone guess this building, where it is, I mean, located in India? Yeah, the participants, can anyone please let me know where this building is, I mean, available?
Sir, they are muted, sir. After the session, they can.
Fine. Right, sir. Right, sir. Right, sir.
Okay.
Yeah. Let me tell the building where it is, I mean, located. So it is at Infosys Bangalore campus. So this is a Infosys Bangalore campus. Okay. So this Infosys, I mean, Bangalore campus, I mean, which is a prime example of an energy efficient building. So which is utilizing renewable energy. Okay. Here, the company, I mean, has installed a large solar photovoltaic system, which is PV systems on its top roof, okay, rooftop. So which is here generating a significant portion of the campus energy needs. Okay, whatever the energy is generating by these PV systems, so it is significantly they are using for the campus energy requirements. Okay, additionally, so energy saving I mean, techniques like efficient lighting. So another things are there which can, I mean, we can save the energy, like efficient lighting and cooling systems and smart energy management, and these things will make this building a model of sustainability. Okay, so this is one of the example which we have already adapted in India. Now come to the another one. So just see this here. Yeah, so several innovative projects across in India demonstrate how renewable energy can power energy efficient buildings. So these buildings are not only, I mean, save energy, but also set a benchmark for sustainable construction practices. Now look at this, another example here, which is Suzlon One Earth, which is located at Pune. So this is another example here in India. So iconic building, it is in India, that utilizes renewable energy in Suzlon One Earth. It is located at Pune. So in this corporate headquarters uses a combination of solar and wind energy to power its operations. See, so this building is using the two renewable resources. One is solar, another one is wind energy is also utilizing here for its operations and all. And here around 90% of the buildings energy comes from renewable sources, so making it one of the greenest building in the country. So this is a real life of example, which is how energy efficient buildings can leverage renewable energy for a sustainable future in India. Now coming to the challenges in adopting renewable energy in buildings here. Now we have some challenges here, so which are nothing but, the first one is a high upfront cost, the second one is technical limitations, then the third one is awareness and education. So let us discuss each and every point here. So to overcome the challenges if you adopt this renewable energies for the buildings. Okay, the first one is here high cost, high upfront cost, which is anyhow, so installing solar panels or wind turbines can be expensive. Yes, of course, it is so very much expensive, and especially for smaller buildings or residential homes. But it is not that much of expensive. Just now I given some of schemes by providing by the government of India, where you have to invest the money at once only. Once if you invest the money, so it will be entire continuously it will generate the electricity. Okay, now coming to the technical limitations here. So in this case, all the buildings are suited for renewable energy installations due to their size, location or design. So while designing the buildings structures, so we have to make sure that whether can we install the solar panels on the rooftop or somewhere else, so the building, so is it possible or not. We have to see all these technical things. Okay, next one is here awareness and education here. So many builders and home owners, okay, so are unaware of the long-term benefits. So that's what I told you just now. So it is a one-time investment. So once we invest the money, so if you for installing the solar panels on a rooftop, so then so it will be long-term benefits of the renewable energy which hampers adoption. Okay, so these are the some challenges which can we overcome here. Okay, now the thing is here, renewable energy reduces CO2 emission from construction equipments, as we know that. So what kind of things can be coming out of the construction here. So now one of the one point I have to mention here, which is the vast amount of technology that is used in the construction of building in a UAE. So uses about 6 billion gallons of non-renewable fuel. So just imagine this one. So this in turn leads to the emission of large amount of greenhouse gases. So because of this, there are significant changes in the atmosphere. Anyhow, so we know that what kind of changes are coming in the atmosphere. So these things are very harmful for the upcoming future also. So we have to think over it. And now, so these are the some renewable energy sources are available. So like solar and wind, hydro and bioenergy and geothermal. Okay, so these are the some examples of the renewable energies, right? Now coming to the solar energy, in depth, let us understand how it will be work here. So this solar radiation is reduced in intensity in the atmosphere by dust, clouds, haze and fog. See, so this is the first thing here. So the radiation by the solar will be reduced here. How it will be reduced in intensity? So by dust and clouds and haze and fog. So generally, more energy will be generating in summer only. So when it comes to the winter season, so the sun will be, this intensity by the sun radiation is very less because of that reason. So we may not get much more energy through this technology. Okay. Then next one is the radiation strikes a solid or liquid, which is absorbed and transformed into the heat energy. So that's what the energy which is coming from the solar, which is nothing but the this photovoltaic. This photon energy is available in the sun energy. So the heat energy is collected and in a fluid generally. So that is a water here. So it can be generated in a heater or a dryer, or it can be treated type collectors. Okay. Now coming to the working of solar power plant here. So there is a two type of solar plants are there, which is the first one is photovoltaic electricity. The second one is solar thermal electricity. So then coming to the first one, which is the photovoltaic electricity. So this method uses photovoltaic cells, so that absorbs the direct sunlight, just like the solar cells. You see on more calculators, which is, no, I told you that. So how much solar cells can be generating the voltages here. And now coming to the second one, which is solar thermal electricity. So it is also solar collector here. So it has a mirrored surface that reflects the sunlight onto the receiver, and that heats up a liquid. This heated liquid is to make a steam that produces the electricity. This is another way of generating the electricity. Okay. Now look at the picture here, where you can see that. So how the solar photovoltaic power plant will be there. So this is how the sun energy will be coming here, and then these are the solar panels are installed here. Then through this solar panel there will be a electric transmission system. So this energy will be through this electric systems, it will be passing through the consumers, whether it may be home needs, we are connecting to the homes, or we are connecting to the industries. So this is the way to generate the electricity and to supply the electricity to consumers. And now coming to the components which is used in PV system. The first one is solar panel. The second one is controller. Then we need a battery. So another one is the inverter. Just now I told you that. So if you want to use anything directly from the solar cell, so there is no requirement of the battery. Directly we can connect the solar cell to the appliances. We can get it. We can get the energy. When it comes to the, if we want to use this energy like in the form of at the time of night duration, so we have to use some batteries here, so it can be stored the energy, and then after that the energy is stored in the battery. So then we have to use this convert this DC energy into AC, which is can be done by the inverter circuit. Okay, now look at the the cross sectional view of a solar cell here. Just now I discussed with you about this solar panel. So how it is looks like. This is a N-type material, and this is a N-type semiconductor, and this is a P-type semiconductor. So these two are combined here. So now here you can see that these are the negatively charged. Okay, these are electrons, and these are the holes are there, which is a positively charged. So these two are trying to cross this junction, but here, so this cannot be travel from P-type to N-type here because of the depletion layer here. Now, so you can see this. There is an electric current is flowing through this. The solar panel, where the sunlight is falling on this. Then the movement of the electrons will start here. So now these electrons will start from this. In this side. Okay, so it will be to the regulator here, and then it will be complete here. Then, so this is the complete circuit here. So how the this solar panel will be working through the sunlight. So these are the batteries so required to store the energy, which is a offline, which is a DC. So if you direct use to any load, it works. Yes, that's what I told you. So we can use directly, but on the time of like night, there is no sunlight in this time. So if you connect the load to active, we need this. That's what. So when it requires, if you want to use this energy, so we have to use this batteries. Okay, so these batteries can store the energy easily, and then after that the energy can be easily converted through inverters, so to in the form of AC, where the electron these are all home appliances is required AC, so then it will be easily work out. And nowadays you can see that in a roadside, where these street lights are also installed by the governments. Okay, different state governments, they have installed these street lights like through the solar panels. Okay, even nowadays there is no human is required to operate these street lights also. Automatically these street lights on and off by using some sensors which used here. Okay, automatically it will be on and off while it is in the morning. So then the switch automatically the light will be off when it goes to the night. It is going to light sun energy is going to go off here, then the light will be on automatically here. Okay, now coming to the controller here, which can control the this voltages here, which is generating by the solar cell, which can charge the batteries, and it will keep away the cell from the overcharging here. Now you can see this here, there is a load also we have connected here. So through this, I mean, controllers, we can apply this to the loads, whichever load is required we have to, so we can use it here. So these are the power inverters, I mean, we have to use here to convert the DC to AC, which is a DC, which can convert to 230 volts AC as per need of the applications. And now you can see that, I mean, there is a wave here, which is a sine wave versus and the actual 60 cycle of the sine wave. Okay. Now let me tell you one point here. So how much this will be generated, the energy here, to calculate the energy here. So to calculate the energy by the produce, I mean, solar panel systems, you have to use some formulas you have to use here. So which is nothing but energy, so is equal to here, which is a panel power, that is kilowatts into sunlight hours. So how many hours the sunlight will be available per day, which multiply with the efficiency factor. Okay, so that is nothing but the panel power will be radiated power of the solar panel in, that is in kilowatts. Then the sunlight hours, which is average number of sunlight hours per day in your location, because different locations, I mean, the sun energy will be, I mean, different. I mean, like sunlight hours maybe varies. Okay. Then the next one is here efficient factor. What is mean by efficient factor? Yes. So which is nothing but the accounts for systems, which is losses due to dirt, wiring, inverter efficiency, etc. All these, I mean, which is in between 0.7 and 0.85. Okay, let us assume that one example I want to share with you here, which is suppose we have a 5 kilowatt solar panel system. Okay, then the sunlight energy, which is per day 5 hours. Okay, then we have a energy that is efficiency factor, which is 0.80. So then if you use this formula, so where we get, I mean, energy which is around 20 kilowatts per day. Okay, so this is how can we calculate the, I mean, the calculation about this, how much, I mean, energy we can generate by using the solar panel systems. Now you can see this, I mean, in this picture, where you can see any number of, I mean, panels we have, I mean, installed here. So this kind of, I mean, things are encouraging by the government of India nowadays. I mean, different states are generating a lot of, I mean, energy through this solar panels. Now the applications of solar energy, which have more applications are there, where so water pumping, and then water heaters, then cookers, dryers, furnaces, and photovoltaic conversion, which is nothing but solar cell, solar power generation, solar distillations, and these are the, I mean, selections here, which is availability of solar radiation. So then availability of large land. So these are the things is required here. So it is depends upon the application. Okay, so availability of solar radiation is also very much important here. So where sunlight will be, I mean, falling continuously, I mean, there is no any kind of, I mean, disturbs here, like availability of large land is also required when it comes to the commercial purpose. If you want to generate the more solar energy, so we need a large land to, I mean, to install these, I mean, solar panels. Okay, so now the second one is here, where accessibility from national highways, which is a transport also, distance from transmission lines, and then local weathering concession. It is also, these are the factors which is affecting for this solar panels for installation, land prices and future prices. So all these, I mean, things, parameters we should, I mean, take care of it here. Now, so there will be some drawbacks also there here. That is nothing but, I mean, it is available in dilute form, and it is a low potential, and the intensity of solar panel, I mean, energy or sunny day, that is India, is about 1.1 kilowatt per meter area. So then it is not available at night during cloudy or rainy days also. That's what I told you in the starting itself, that so these solar panels will be much more useful in summer season. Okay, now this is the some statistical, I mean, analysis. I mean, this how much, I mean, megawatts the capacity of India in a different states here. You can see this Andaman Nicobar, which is, I mean, around 5.10 megawatts it is generating here, and Andhra Pradesh. You can see there is a two big states are there which is generating more, I mean, electricity by using these solar panels. One is the Andhra Pradesh, another one is this Gujarat. Yeah, Gujarat is also having, I mean, much more electricity, which is generating by 1024 megawatts here. And another one is in a third place, which is Punjab, where it is generating 300.2 megawatts. And similarly, so yeah, Rajasthan is, I mean, the biggest, I mean, solar panels, I mean, these plants are available. so which is generating 1264.35 megawatts. The total energy which is coming throughout the state, I mean these states, which is around 3654 megawatts electricity is generating here. Now, so coming to the next, resources, which is wind energy here. Let us discuss about, this wind energy. So let us, introduce about this, wind energy, which is atmospheric air in motion, which is atmospheric air in motion. Then it has become an energy source. This is also one of the source here. Then sun, here one comparison is given here, which is sun produces, which is 4 into 10 to the power of 26 joules of electromagnetic radiation. So every second that is radiated into space. So this radiation will be, going through the atmosphere here, through the sun here. Then about the 2% of the sunlight that falls on the earth is transformed to wind energy, and wind provides around 1% of the world's electricity. Now look at the growth rate of this, wind energy, which is worldwide. The total cumulative installed electricity generation capacity from wind power around 4,32,883 megawatts. So this is the electricity which is generating through this wind power. Okay, and it is increasing in 17% compared to the previous year, which is a global wind power installation increased by 63,330 and megawatts. Along with that, these are the different megawatts power which is increasing in every year. You can see that. So respectively, 2013 and 14, 15, in every year the energy, this megawatts power is increasing here. So because we are installing more this wind turbines. Now this is somewhat the analysis here, energy output by the fuel type here. So this is the nuclear, which is around 60%, and hydro is 24%, and 10% is by the gas, and 6% by the wind, and some 1% as well as biofuel, as well as the solar, other things. Now coming to the wind information here. So how this wind can be generated here, created here, which is the first one here. Look at this here. Wind is caused by differences in the atmospheric pressure. When a difference in atmospheric pressure exists where air moves, this is the air flow here, how this wind will be generating here. Air moves from the higher to lower pressure area, resulting in wind of various speeds here. Okay, then the two major driving factors of wind patterns are differential heating between the equator and the poles here. Now, so each and every second, the sun releases an enormous amount of radiant energy into the solar system here. Some of the, it reaches on the earth here. Look at this. So strikes the equator directly, giving the most radiation, and diffuses along the northern and southern hemisphere. And the poles receives the lowest amount of radiation here. So this is how the flow of air will be there in. And look at this here. So this is how rotating machines that can be used to generate electricity from the kinetic power of the wind. Okay, like aircraft propellers and turn in moving air power the electric generators, supply electric current. So for fan we required electricity, and then it will give the wind like it will give air. Now for turbines, so we need wind here. So when this wind okay, for turbines, when it turns, okay, then it will generate the electricity here. Wind rotates here the turbines blades here. So we have a turbine blades are available in this wind turbines. So there, some areas we can see two blades are there, some three blades are also there. Different types of turbine blades systems are available. So which can spins a shaft connected to a generator. So the spinning of the shaft in the generator makes electricity. Then efficiency depends upon number of blades in windmill efficiency as blades. So this is the major thing here. So we should look at this here. So efficiency depends. It means that so number of blades we are using for the windmill, so it will give more efficiency here. Actually here one more point. So we have a different wind mills are there, where by using two, like a single blade is also there, double bladed windmills also there, and three bladed windmills also available. So you can see them these are the three comparisons are available for the different windmills here. So rotor must move more rapidly. So these are the comparisons. I don't want to much go in this comparison, because all these are using, but nowadays we are using 3-bladed windmills here, okay, which can give more energy compared to the others. Now these are the two different kinds of wind turbines are available. The one is the vertical axis, and another one is here horizontal axis. So this one is more popular, where you can see in India. So this kind of windmills are available in all the places. Now, so if you look at this here, so what is the comparison of these vertical axis and horizontal axis? Now this is the new technology. Not only not the new technology, where some areas are there where you can use this vertical axis and horizontal axis also. See, so there will be a rotating axis, and of the wind turbine is vertical, that is perpendicular to the ground, and here that is horizontal of or parallel to the ground. There it can be generated for the this vertical axis for the residential applications only, and this primarily used in a big wind applications. Okay, in horizontal axis we use for big wind applications. And one more point here, which is powered by the wind coming from all 360 degrees, no air machine. So there is a one of the beautiful the facility which is providing in this windmill, which is nothing but, suppose we installed a this wind turbine, this windmill at one place where the air is coming in this direction. Okay, suppose when the wind is coming in one direction, so we installed this this fans, this wind, okay, wind turbine, so installed here. So it is while the wind it is start rotating, then electricity will be generating. Next thing is here, when the wind is not in this direction, so the question will come here, suppose there is no wind in this direction, so then what will happen? So the anyhow we know that, so this this will not be move. Okay, so in that case what we have to do, so there is a one of the beautiful sensor application we are used here. There is a one application we used where, so this this wind mill will be rotator. So accordingly where the the wind is coming, so it will move into the 360 degrees. So then it will start rotating. So in this way we can easily generate the electricity by using this wind. Now look at this comparison of this horizontal axis and vertical axis. The comparison here, factors, a lot of things are there here, where power generation and efficiency. You can see that in horizontal, where you can generate only 50 to 60% only now, but in a vertical, so you can see that there will be a more electricity will be generated, which is around more than 70%. Then steering mechanism of wind. So here, so there will be a, yes, it is available here, but in this case it is not available here. The blade rotation speed here quite large and then quite small. So in this case, a small blade rotation is there, which is speed of the blades, and resistance capability and noise. Yeah, one more point here. So why these windmills will not be installed at the nearest to the cities or villages nearby, because it will make noises. That's the problem here. So it will make the noises which is around 5 to 60 decibels, and here in vertical, which is around 0 to 10 decibels, the noise it will be generating here. Then steering wind speed, the speed of the wind which is around high here, and here it is low. Then failure rate and maintenance. So in this horizontal axis, which is complicated, that is maintenance, and it is convenient here. Then rotating speed and effects on birds. Yes, this is another point. People are raising the issues here. So when we install these windmills, it will be harmful for the birds. When it any bird will hit on the this blades, it will be die. So that will be a problem here. And here in this case, which is a great possibility is there, effect on the birds. And in case of vertical, there will be a small possibility. So in this then cable standing, there is a problems also there here. Okay, now coming to the working principle of this wind turbines here. Now look at the picture here, where you can let us try to understand how this wind turbine system will work here. Okay, now you can see here a lot of things are available in this wind turbine system. There will be a pitch is there, and rotor is available here. Then gearbox, generator is there, controller, and then this is an anemometer. Just now I told you that there is a possibility, I mean, this blades will be changing the direction, okay, changing the direction, okay. This will be, I mean, indicates that, so which direction the air is coming, okay, immediately. So when the direction of the, I mean, air is changes, then it is automatically, it will change the entire this, I mean, this panel, okay, so into that direction, so that the blades will be start rotating here. Now this is the entire system here, high speed, I mean, shaft is now this is the point here where the electricity will be collecting here. So this is the high speed shaft is there, so here we collect the electricity. Then these are the brakes and yaw drive and yaw motor, and this is a blade, these are the blades. And let us, I mean, go through one by one here, which is a pitch here. So in this pitch, this turns blades out of the wind, I mean, which controls the rotor speed, and it keeps the, I mean, rotor from turning in winds that are too high or too low to produce electricity, okay. Now this is the next one is here. Let us come to the rotor here. What is the rotor part, I mean, here, which blades and hub together from the rotor here. Next, which is, I mean, tower is there anyhow, so this can be, I mean, holding the entire system here. Then wind direction here, which is determines the design of the turbine. Then upwind turbines like the one shown, I mean, here the face on the wind, while downwards turbine for face away, okay. Now then we have a wind ware here, then yaw drive, yaw motor. Like let me give you one small example how best, I mean, to understand the working of this the entire turbine system. Let me tell you one thing here. There is a bicycle is there. There is a bicycle is there. So when it is in a standing mode. When it is in a standing mode, so you just, I mean, use the stand, and then it is a static mode, okay. Now you just, I mean, use the pedal, okay. Once you rotate the pedal, what will happen? The tire, I mean, the next the second which is one connect two, I mean, two tires are there here. So these that will be one backside, I mean, wheel will be start rotating. So when you push the pedal, then the backside, I mean, this wheel will be start rotating here. So once if you start, I mean, if you press the pedal very, I mean, in a force way, I mean, if you apply the force on a pedal, then the wheel will start rotating very fast, rotating very fast in a similar way. So this, I mean, these are the plates are there. So when these plates are starts moving, okay, starts moving, then this gearbox and this will generator will be, I mean, start rotating very fast. Now here what will happen here? The mechanical energy will converting into the electrical energy. So that is the principle which is involved here to generate the wind energy into electricity. Now also these are the setuping types are there, which is a standalone type, which is there is no connected, I mean, a power grid, and power created is directly channeled into the power site. And the second one is here utility, I mean, how the utilization of the power grids, which is store energy connection must there will be, I mean, combination and photovoltaic cells. So now you can see here there is a, I mean, two things are connected here in this picture. So one is wind turbines is there, and then another one is solar panels are available, which is a PV array, and which can be stored here, which is a solar charge controller. And here it is, I mean, wind controller is there. See, it is also required here. So wind control is also required. Why? Because sometimes in rainy season, the air will be very much high, okay. So in those cases, it will be, I mean, possibility of the damage of this wind turbine. So in that condition, we have to control the fan speed also. Otherwise, I mean, it will be may get damaged. So, and one more, I mean, lot of issues are there with this, like installing at the time of installing of this wind turbine. So we have to carry these, I mean, blades very much, I mean, big size these blades are there, and these blades we have to take into the location where we have to plant, okay. Then through that, I mean, transportation, it is very tough to us to, I mean, bring these, I mean, blades at the location. Now, so when the energy, I mean, is coming out from this solar and wind turbines, then it will be stored in a battery tanks. Then it will move to the DC loads. Just now I told you that, I mean, that is in the form of batteries. Then this energy will be converting into DC into AC. Then these are the AC loads for our home appliances, where we used AC loads and all. So these are the applications of, advantages of these windmills, which is a very low carbon dioxide emission. This is a very much, good application that. So zero once, once it is constructed, so this will be a very low carbon, dioxide emission. It will not. And the second one is no air or water pollution. There is no pollution at all from this, but only the thing is it makes some sound. There will be a noise will be generating through this windmills. No environmental impacts from the mining and drilling. So this is also one of the advantage here. Then it is completely sustainable, like unlike fossil fuels, and wind will never run out. Yes, this is the, so wind will be coming in the entire different all the seasons. Okay, so I told you that wherever the direction of the wind is there, so then this device will be turn around the blades, so then it starts working here. So it will not be in a normal stand position, then it will start rotating wherever that wind direction is coming. Then turbines work almost anywhere in the world where it's a reliable windy, or unlike fossil fuel deposit that are concentrated on only in certain regions. Okay, unlike fossil fuel powered wind energy operating costs are predictable years in advances. So freedom from energy prices, that is a political volatility of oil, gases, supplies from other countries. So then new jobs in construction, operation, and manufacturing of turbines. All these are areas of the advantages. Now we have some drawbacks, that is nothing but disadvantages also there here. So which is a high upfront cost. The cost is very much high. So we have to bear that much of cost. If you require for commercial purposes, so one-time investment, and at the same time some maintenance is also required here. See here, extra cost and complexity of balancing variable and wind power, so with other forms of power. So extra cost of upgrading the power grid and transmission lines, like whatever the energy is generating by the this windmills, then through transmission lines the electricity has to be passes to the consumers. Then so there will be a damage of the local wildlife. Just now we discussed about that. It will be damaged by the for the these birds and all. So large overall land take. So there is a it is also required, that is land is also required here. At least 95% of the wind farm land can still be used for farming, and offshore turbines can also build in at sea. So there is another way can generate the electricity at offshores. Okay, there is a turbines we can build at sea. Okay, so then so it cannot supply 100% of the country's power of all year round, which is the way of fossil fuels, nuclear, hydroelectric, and biomass power can. Okay, then loss of jobs for people working in mining and drilling. Anyhow, so these are the some disadvantages of windmills. Now coming to the wind power in India. So this wind power will be developing in India. So the first wind farms being set up in coastal area, which is Maharashtra, so Ratnagiri, and Gujarat, Oka, and Tamil Nadu, with 55 kilowatts Vestas wind turbines. This is the first time we installed these wind turbines, wind power development in 1986. Now these demonstration projects were supposed by the Ministry of New and Renewable Energy, which is controlling all the things here. So these people will take care of this. And as of this is 2016, the capacity wind power in India, which is 27,441 megawatts, with southwest and north areas including the major part. So this is the somewhat analysis of which is generating in India, so through wind power. And now look at it here, where National Institute of Wind Energy so has been established in Chennai, so in the year of 1998 as an autonomous and R&D institution by the Ministry of New and Renewable Energy, which is Government of India here. Now these are the some places where it is located, and then the energy which is generating here. Now look at this picture here. So where wind pattern in India. Okay, so this is the direction of these arrows. So you can see that how the wind will be the direction of the wind will be throughout this country, which is India. So in summer, okay, in summer the direction of the air will be in this way. Okay, in winter, so it is quite opposite. The winter from top of the India states, the wind will be start coming here in this direction. Okay, so this is the direction of the wind pattern, which is in India. Now so this is the installation capacity. The throughout the year. So how much installation is done here. And now, so Indian renewable energy scenario here. So how much energy we are generating through different resources. One is wind power, which is around 65% energy we are getting through the wind. Okay. So and next one is here a small hydropower. As you all know that because you people are good at this hydropower and all. You know much better the hydropower here. So through water, we can generate the electricity also, where the big dams are, there, so it can generate the electricity through the water. And we have a 11%, electricity can be generated by the biomass power. After that, we have a solar energy, which is around 13% energy we are generating, okay, through the solar panels. Now this is onshore, so where land on the land, so these turbines are located here. Then it can be generating the capacity which is around 49,130 megawatts here. So then at higher hub heights, the potential of 49,000, and the height is also very much important here. So which is around 50 meters level. So where you can generate the electricity which is around 49,130 megawatts we can generate at the level of 50 meters. Now if you increase the height of this turbine, this entire this windmill, so which is around 80 meters, where standard hub height that is expected wind potential energy, which is increased to 1,02,788 megawatts. Okay, so this is how the main changes will be done when the height will be increased here. Now this is the Indian wind power density here, where you can see that. So these are all places there the red color is mentioned, which is around 200 to 250 okay, and along with that other places also these wind turbines are established here. So through this the entire country is generating this much of wind energy here. And now look at this the capacity here. So through different states, how much megawatts power generating here. So Tamil Nadu, the first state which is generating 7,684.31 megawatt capacity it is generating. Okay, now come to next one is Maharashtra, and along with that Gujarat, Rajasthan, Karnataka, Madhya Pradesh, and Andhra Pradesh. So all these different states are generating the this electricity through this windmills. So the totally we are having 28,082.95 megawatt electricity are generating throughout this all these states. Now, so the target by the Indian government, which is 140 gigawatts by 2030. So this is the target set by the government of India, where we have to get this much of energy. Okay, and now utility scale of onshores, which is 58,000 megawatt, and offshores, which is 1,500 megawatts, and distributed power, which is 500 megawatts. Now the another way of the generating the electricity through this offshore also, where these turbines this windmills installed and see here. So India's coastline of around 7,600 kilometers and exclusively economic zone of over 2.3 million square kilometers provides good potential for offshore and wind power development. So this is also one of the good beautiful good thing for India, that is this much of big coastal area we have where we can install this turbines, this windmills can generate the electricity. And offshore wind energy steering committee, which is this is the committee which is taking care of this, constituted in 2012 to suggest a policy framework on and interagency coordination. Then so Ministry of New and Renewable Energy has prepared and issued draft national offshore wind energy policies. There will be some policies which is prepared by the government of India. So we have there these commercialized people has to be follow these all policies and all. Now the features of this wind energy, which is like main features here. So National Institute of Wind Energy, which is single window agency, and there's another one is which is coordinated with the CARS and SCRC for traffic setting, tariff setting and regulatory issues here. So then EIA study of proposed offshore wind farms regarding aquatic life and fisheries, marine life, archaeological remains, and to be conducted by the developer. So these are all the features of this windmills and all. Now India's exclusive economic zone here. So in this is the country, this is the coastal area, so which is having India here. So in this areas where the this offshore windmills are established here, installed here. So this is the potential offshore zone here, and here also one more which is a potential offshore zone where, so we can see that at Tamil Nadu and at Maharashtra and so the Gujarat place also, it is very much useful here, these facilities. Now, what is the comparison of this onshore and offshore here? So because of the onshore, it is on land. If you install this wind turbines where the speed is very much moderate. Okay, when it comes to the offshore and sea, where, high speed wind turbines will be there because the continuously the air will be more here. So that's why the speed will be increased here, and damages to human life onshore, and then here no damages to human life because it is offshore. These windmills, wind turbines are installed here. So bad visual impact, and then that is on low erosion and zero visual impact, low capital cost, high erosion. So these are all the comparisons of the onshore and offshore. For when you are going to establish this type of windmills. And now, so these are the RE incentives, which is tax and non-taxes here, investment tax credits and investment allowances, accelerated depreciations and depreciation and tax holidays. All these tax and non-taxes, which is incentives here. And now this is the conclusion part, which is about the wind energy, which is energy demands across the world. So including developing countries like India has led to develop the depletion of fossil fuel, which all through provides energy in enormous quantity but affect the environment. As we all know that, so why we have to opt this, renewable energy sources technology, because to save the environment, okay, so that we can give the best future for our upcoming our nation and all. Hence, to protect the environment from hazards, which is other resources, including wind energy, is to here. It has provided to compensate for energy very well. And the future looks bright for wind energy because technology is becoming more advanced and windmills are becoming more effective. That's what it is more effective. We are using and we are generating the electricity also. And now wind energy is rapidly increasing with the passage of time. Government as well as the world is putting effort to understand its importance and bringing best out of it. And even we have a lot of policies are there to harness to recompense the hike in energy demands. So this is about the presentation from my side. So I request the coordinators, please.
Yes, sir. Thank you, sir, for the wonderful session. So, participants, if you have any queries, you can post your questions into the chat box. Once again, I'm repeating, participants, if you have any queries, you can post the queries into the chat box so that our speaker will clarify your doubts.
Okay, the question from Muhammad Imtatullah Khan, which is what are some challenges associated with promoting energy efficiency? Yeah, good question, sir. So we have some challenges are there here. So which is nothing but the first one is initial investment cost. So which is energy efficient upgrades can require upfront, which is an investment which can be barrier for individual and businesses. Then second one is lack of awareness and education. So many people are not aware of the benefits of the energy efficiency or the available option for saving energy. Now coming to the next, the challenge, which is a lack of incentives. Government policies and incentives can encourage efficient energy efficiency, but they may not be readily available or sufficient to motivate widespread adoption. Because now Indian government is taking the initiation that they are giving a lot of initiation incentives to install these solar panels, and these are all the windmills and all. Okay, next one is here technical complexities also there, which I have discussed in the presentation, which is implementing energy efficiency minutes can involve complex technical considerations will be there here. It requires expertise in area like building science and engineering. So all these are the challenges which associate with promoting the energy efficiencies.
The next question is from, is there any impact like climate change which affects with wind energy? Dr. R. Kangraj.
No, actually, for I mean this climate changes. Like, see, I already discussed that. I mean, suppose this wind mills will be much more. I mean, useful at the time of the rainy season, because where the I mean the wind will come more and more. So then we increase. I mean, produce the electricity more and more. So, so instead of some other, I mean, seasons like other seasons, the wind will not be much more. So those conditions, it will not be, I mean, much effective here.
Okay, sir. Next question is, what are your thoughts on the future of energy efficiency?
Yes. Okay. See, actually here there will be some future energy, which is nothing but so wider adoption of energy efficient technologies, like as cost decreases and benefits become more apparent, like energy efficient technologies will become more commonplace. So that's what I told you, that so people will start adopting this facility here. Then it will be useful also, and integration of smart technologies like smart grids, building automation systems, and IoT devices will play a crucial role in optimizing energy usages. Okay, and then greater focus on behavioral changes, also public awareness, that is it's a more important thing. Now people are, I mean, getting awareness on this, so they started, I mean, buying all the, I mean, the solar panels, and then they are installing at their, I mean, homes and all. So they are getting a lot of, I mean, benefits. So how this, I mean, comes into the, I mean, throughout the, I mean, the humanity, which is nothing but we have to give some awareness, I mean, campaigns, then which will be very much useful for them, so that, I mean, we can increase that. Then next one is here, so the policies which by the government, so and incentives which will be more, I mean, implement more robust policies, that is incentives to promote energy efficiency and reduce carbon emissions. This is one of the application of this, I mean, using these renewable energy sources.
Okay, sir. Next question from Alex. Sir, can you tell me some of the research areas in renewable energy sources?
See, we have some research renewable energies also. So where, I mean, we can do the research on like uh, uh, like uh, mm, so environmentally friendly solvents, like fabrication of voltaics, and then hazards solvents and their implementation and manufacturing.
The next question is from Anil Kumar, sir. What are some common energy efficiency measures in buildings?
See, actually, nowadays, in every, I mean, all these, I mean, high-rise buildings, most probably we are using solar energy. So where we can easily, I mean, install in the place of, I mean, these like glasses and all. So we can easily install these. Like just now, I have shown you some pictures of the Indian buildings, where one is, I mean, Switzerland building, another one is, I mean, Infosys campus. So, and even nowadays, I mean, many places where we are using this, I mean, solar panels, installing. Even government also, I mean, initiated that. Many, I mean, railway stations already they adopted. I mean, they have taken the initiation. They started, I mean, installing the solar panels. So where which can give them more energy for the, I mean, the requirements.
The next question is, what is the Energy Star program?
Yeah. So energy, star. So it is actually Energy Star is a voluntary program, so which can run by the U.S. Environmental Protection Agency, which is the EPA. So which identifies and promotes energy efficient products and practices. Okay, then the products that meet specific energy performances standards are awarded the Energy Star labeling. Okay, making it easier for consumers to choose efficient appliances, then electronics and other I mean, products here. So this is nothing but the Energy Star program.
Okay, sir. From next question, Dr. Supratim, is CRZ ecosystems are getting hampered for these windmills?
Yeah, of course, yes. So there will be, I mean, some issues also there, I mean, with these windmills and all. Like I told you that in the presentation, that, I mean, there is a problem with the windmills. It generates some more noise. It is a noise. It creates some 0 to 6, 6 to 10 decibels. The noise it will be generating here. Okay, and ecosystem also will be there here. It will be disturb the entire system.
Okay, sir. From next question from Dr. Rachna. What is the role of energy efficient buildings in the broader context of urban planning and reducing the climate impact?
Yeah, see, actually, once we start, adopting these technologies, of course, definitely we will not, depends on the these energies which electricity generating, coal we are using to generate the electricity, and other, some electricity generating by the other sources. So because all these are, damaging the environment. Okay, so once we start, using these renewable energy sources, then it will be, so global warming will be reduced here. So it is and one more point, that's what I told you that. So in the starting itself, where this the one-time investment, if you start doing, then it will be more useful for us for the long run.
Sir, how can cities seamlessly integrate
Yeah,
energy
one more
efficient?
question is there here. What are some key energy efficiency standards and regulations? Yeah, let me tell you, this is a very much important question here. So here we have a key energy efficiency standards are there, which is regulations. Like the first one is Energy Star. Okay, so it is a voluntary program that sets energy performance standards for appliances, electronics, and other products. Then next one is here LEED. See, this is the leadership in energy and environmental design. Okay, so a rating system for green buildings that included energy efficient criteria. See, generally, as you see that, this green building, so the ratings, so how these people will give the ratings, so based upon this leadership in energy and environmental design systems, so where rating systems will be given for the green buildings, that includes energy efficient, how much energy efficient will be there in the building structure. So it will be giving the more star rating for that. And building codes also, and government regulations that mandate minimum energy efficiency requirements for new and renovated buildings also. See, generally, if you start new building, then we can design as per requirement. Then if you start doing the renovation of the buildings also, but it takes redesign the building and all, it will take okay. Next one is here energy performance standards, which is appliances, that is regulations that set minimum energy efficiency standard for appliances like refrigerators, washing machines, and water heaters. So all these are the key energy efficiency standards and regulations.
Sir, okay, so next question is, sir, how can cities seamlessly integrate energy efficient solutions into public spaces?
Yes, actually, see, one more, beautiful application is there, like this wind. See, if I'm not wrong, so there will be one new thing already, started working. So like in highways, where this, wind, small wind mills has installed. So where when the vehicles are, moving on the roads, then so the air will come. Okay, there is a fast, wind will come. So that wind is also utilizing for the generating the electricity. Okay, so in these type of plants, so can be easily generating the electricity.
Okay, sir, thank you for that
Yeah.
for clarification. So I think questions are over. Participants, if still you have any queries, please post as soon as possible in the chat box.
Yeah, I once again thanks for the Civil Department of Lord's Institute of Engineering Technology for giving this opportunity to share my experiences in this area. Thank you very much, sir.
Thank you, sir.
Thank you, sir. Thank you, sir. Nice presentation. Wonderful section, sir. Once again, thank you.
All participants, your online test timing, sir. Our coordinator, sir, has been posted in the chat box as well as WhatsApp group timing. So after that online test, there will be a validatory session which ends the FDP of 13 sessions of 6 days. Participants, again, the coordinator has posted in the chat box that after the session 13 ends at 6:30 p.m., we will provide 10 minutes for participants to prepare the details before the online test begins.